Am I audible, guys? Hello.
Yes, sir.
Yes, sir.
Just a second. Is my screen is visible to you?
Yes,
Sir,
sir.
I have a doubt in sir week 11, sir. Can I
Okay.
ask?
Yeah, you can ask it later, but today the today's agenda is to week 1 to 9. Okay, so today we will covering
Hmm.
all the problems from week 1 to 9.
So just you briefly tell me the Dijkstra algorithm and Bellman code.
I will take your doubt in the last.
Okay,
Okay.
sir. So can I join? Which time I
Mm,
will join? 9:30?
no, today, yeah, you can join at that time. So yeah, let me start with it. So today we will be covering today is the revision session for week 5 to 9. So let's start with the revision. So we have one function, right? So we already know what is a one function and what is a function. So first of all, what is a function? So a
Uh,
function is a mapping from A to B, right?
yeah. And
Voice is clear.
yeah, sir.
Mapping from A to B. Okay. So what is a one function?
Which fails to.
One
So
output have
Uh,
one input.
yeah,
for
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 one
every
input we get
in
you,
for every distinct output, there will be a distinct input in the domain.
for distinct input you will have distinct
Distinct
output.
output. Hmm.
Just a second.
Hello, sir. We will get notes of it or not?
Is class started?
Hello, sir.
Hello, am I audible?
Yes,
Yes, ma'am,
ma'am.
you are audible.
Yeah, actually, Abhishek joined the call mistakenly. It was not a TA session. It was in.
It was instructor session.
Yeah.
That's why I'm.
Statics.
I was waiting because I was confused what is happening here.
Hmm.
He joined mistakenly, actually. Okay, so we shall
So,
continue.
ma'am, can you please clear the doubt of my Dijkstra algorithm and Bellman code?
No, actually, in today's session, we will discuss from 5 to 9. Um,
Yes, ma'am.
Okay, after that ninth, if I get time, then I will discuss your doubts. Okay.
After?
Yes, ma'am. We'll finish this
the theory part because last time also it was time taken. So
Yeah.
finally we taken all the doubts, ma'am. Don't let people ask them doubt in between, ma'am.
Yeah, sure. You can ask doubt in between, but let us first cover 5 to 9, which is today's aim. Then, like if you have any doubt beyond that, I mean 11 and 10, then you can ask about it. Okay.
Yes, ma'am. That's what I'm saying.
Yeah. Okay, my screen is visible, right? Is it visible?
Yes.
Yes, ma'am.
Yes, ma'am.
1000% visible.
Okay. Okay, we shall start then. Today we will cover from week 5 to 9. So just let us first recall the topics. So which I'm going to cover today. First we had the exponential function, right? Then we will revise logarithmic function. Okay, so these are the only topics we have to cover, right? Is there anything else rather than this? No, right? Okay. Then we, yeah. Okay. Then we shall start. So we will start with exponential function. So just to recall, because all of you already know what an exponential function is. So first of all, we know what a function is, the definition of function or properties of functions, right? Then we have exponential function. So exponential function is a function in this form. So where a is any real number except the point 1 and x is any real number. Okay, and when we are saying that x is any real number, that means the domain of the exponential function is real number set, right? Domain is real number. And what we know that exponential function maps to only positive numbers. That means the range is 0 to infinity, right? So
Ma'am, A is only a real number or positive, ma'am?
Yes, positive.
positive. Because here we are not allowed to take complex number, so we have to take positive real numbers other than 1. So when I'm saying this positive real number other than 1, that means we have two possibilities. Either a can be in this interval or a can be greater than 1, right? So based on these things, we had a picture, right? So if a is greater than 1, then we have this type of picture. This is a greater than 1. The graph is a power x. That means from the graph, it's clear the properties of exponential function. First, it's a 1, 1 function, right? Because it will pass the horizontal line test. Secondly, we can say it 1, 1 as it is monotonically increasing, right? It is monotonically increasing function, correct? So it is a 1, 1 function. Secondly, it is a onto function because it will go up to 0.
Can you remind monotonically? I just forgot.
Okay, monotonically increasing means it will go in this increasing order constantly. That means if at any point of the domain x1 and x2, if x1 is greater than x2, then the functional value of x1 will be greater than the functional value of x2. Okay, so this was monotonically increasing. Okay. And if monotonically decreasing means if you take any 2 points from the domain x1 less than x2, then it will imply f of x1 greater than f of x2. That means the opposite inequality. Okay, then the function will be monotonically decreasing. That means function like that, right? Sorry, like yes.
How it was a onto function?
Okay, so as in the last class I also told you, okay, once you want to find a function onto, you have to check the domain and then the range. If the domain is equals to range, then the function is onto, right? So we have the range is 0 to infinity. That means from here to here, right? And the range is also 0 to infinity, right? Because we can see the function is like that. So it will go up to infinity in the increasing direction and also in the decreasing direction. When x is going to minus infinity, the functional value is tending towards 0. That means we will touch open interval 0, right? So the range will cover the whole domain, I mean codomain, right? So basically here range equals to codomain. That means this function is on.
Now, as we assume it's minus infinity is parallel to 0, then it's sometime, it's some place, it is like a plane and parallel, then it's not onto no,
No,
because
no.
we can,
Here we fixed our codomain, na? This is 0 to infinity.
Ma'am,
Yeah.
if we don't assume that we don't restrict that the range from 0 to infinity, then it will be not onto, na? We restrict it, that's why it's
Yeah, obviously. You can, if you just change the codomain, you cannot change the range because the range is something unique if the domain is fixed. But you can change the codomain. But what I am saying is in this range and codomain, that means from real number to 0 to infinity. Okay, so I am saying it onto means it is onto in this codomain. When the
Ma'am, but
codomain is 0 to infinity.
how are you finding the exact range? Because I think the range should be 1 to infinity, but it didn't include 0 here.
No, no. When x is tending to minus infinity, then a power x will be tending to 0, na? So it will contain open interval 0.
Yeah.
Right?
Ma'am, can we discuss a little bit of composite function also?
Sure. Okay. I will discuss.
Ma'am, I am facing a lot of problems in the finding domain, codomain, and range in the given graphing function.
Okay.
Ma'am,
Yes.
when you said that it is monotonically decreasing, so what will the value of A be? Like an example?
It is monotonically increasing. That means if you can, this is the domain, right? So if you can pick any 2 points from the domain, suppose x1 and x2, here we can see that x1 is less than x2, right? That means
Right.
x2 is greater than x2. Now, if
Right.
you can check the functional value, so this is the functional value of f of x1, like x1, and this is the functional value of x2, right?
Yes, ma'am. That I understood. I was asking about the decreasing part that you mentioned.
Okay, decreasing part. So if you take this interval, then you will get this type of picture, right?
Okay,
Exponential.
okay.
So this is an example of decreasing function. Okay.
Thank you, ma'am.
Yeah. Okay. So so about range and domain. First of all, domain is a set in which you can define a function. That means once you are fixing a set as a domain of some function, that means the function should be defined at each point of the domain. Okay, so domain you have to fix in this way so that you can define the function at each point of the set. Okay, and codomain you have to you can take codomain as a large set, but if once you want to fix the range, you have to check the images of the points of domain under the function. So just for example, when we had the exponential function a power x and the domain was R, now suppose you want to check the range. So you have to check at the boundary points of the domain. Okay. So what is the boundary points of real number? This is minus infinity and plus infinity, right? So you have to check at minus infinity and at plus infinity. So when x is going towards infinity, the function will be going to infinity. And when x is going to minus infinity, then the function will be going to 0, right? Once you find the behavior or the images of the function at the boundary point, then you can say about the range. So our range now become 0 to infinity. So this is a typical way you can construct the domain and the range of some function. Okay. So as I was saying about exponential function, so typically exponential function look like this. Whenever a is greater than 1, and look like that whenever a is greater than 0 and less than 1, right? That means when a is greater than 1, we have the function is increasing, the function is bijection, right? And when the a is in the interval 0 to 1, then the function is decreasing and the function is again bijection, right? So we know that when a function is either increasing or decreasing, then the function is 1, 1, right? And also in its range, the function is always onto. Hence, in its range and domain, the function is bijective. Okay?
This is for a power x.
Yeah, a power x.
Ma'am, here a is cannot is equal to 1, na?
Yeah, a cannot be equals to 1 because exponential function means we always take it as something increasing, which is non-constant function. But if you take a equals 1, then our function will become 1, right? That means 1 power x means again 1, right? So it will become a constant function, right? So if I take 1 instead of a, then there is no value of the point a, right? That is why we don't consider the point 1. Okay, so just to recall, exponential function we can express as a power x, where a belongs to 0, 1 union 1, infinity. Exponential function is always bijective and it is either monotonically increasing when a is in this interval 0 to 1, then the function is monotonically decreasing. If a is greater than 1, then the function is monotonically increasing. Okay, but that much information you have to keep in your mind, okay, about the exponential function. Any doubt?
Ma'am, a will be always greater than 1, na?
No, a can be less than 1, but greater than 0. Which if
What
a
first
is
line,
0
0 to 1 and
we cannot
what?
take any negative point, because if we take any negative point, then suppose minus 1 power half, it will be complex number, right? So because we want to avoid complex number here in this course, so we will not take any negative number here. Okay.
No, it's first
Ma'am,
line A belongs to 0 to 1. B
ma'am, why we took a break
1
between
is signed as
0
0.
and 1, union
One
1 and
again.
I mean, first line function ax belongs to a belongs to 0, 1, and what you written? B.
1 to infinity, union 1 to infinity.
Actually, union also.
Yeah, that means we are excluding the point
Yeah.
1
So,
from
ma'am,
the
it is the range of a. Ma'am,
yes.
0,
Range.
1,
No,
union
no.
1,
This is not range. This is the possible value of a. This is neither domain nor range. This is the possible value of a. Exponential function. So from where you can take the x, it is called your domain. A is just a
So
constant,
ma'am,
and
we
you
can
can
directly wrote it as 0, infinity.
no, because
No,
we
because
cannot take the point 1 now. At 1, the exponential function will be a constant function, which is not possible now, which will be contradicting to the definition, right?
We can write it as 0 to infinity except 1.
Yeah.
So
Also,
ma'am, why are we taking union? We can intersect it, na?
no, intersection is fine. Na? Union means we will take this whole set -1.
intersection is only that is
Intersection means
involved.
the points which are common to both the sets. Union
That
means
is
you can
no.
collect all the points.
The
Okay.
intersection would just become 0 to 1 if you would do that. That would not make sense.
No,
Intersection is
intersection is 5.
no.
Intersection is 5. 0 to 1 and 1 to infinity. There is no intersection in this set.
Yeah, that's what I'm
Yeah.
saying, ma'am. If it was intersection, it would limit itself to 1, which makes no sense.
Yeah.
Ma'am, but you have said 0 to infinity as a range. So we can get any value, ma'am,
Yeah.
as an output.
Yeah.
Yeah. Okay.
0 to infinity is the range. That means if you take any point from 0 to infinity, there will be a pre-image for that point under this function.
So, ma'am, there was something you mentioned about minus infinity to infinity. Just go up. I think you wrote something. I don't know what it was about.
Okay, minus infinity to infinity is, that means your domain is the real number, right? And the boundary point of the domain is minus infinity and plus infinity.
Just go up now, ma'am. I just want to see what was written. Somewhere up. I think there was something. Just go up. Oh, that's it. Okay. Okay, ma'am.
Ma'am, exponential function is a bijective function, no?
Yes, right. From its domain to range. That means real number to 0 to infinity is a bijective function. That means invertible.
And ma'am, will we get the notes of this PDF?
Sure, I will share after the class. Okay, so this is
Ma'am, week 9 to week 12 have the most weightage in the end term, right?
yes.
Okay, thank you, ma'am.
Yeah. Okay.
Excuse me, ma'am. Ma'am, where did you upload the notes of yesterday? I did not get it.
Yesterday means?
Yesterday revision class.
That means yesterday
Last
means
session,
that.
ma'am.
The calendar, ma'am.
Okay, last session I uploaded the PDF in the chat box.
No, ma'am, it's also there in the calendar, I think.
No, it is not in the calendar.
No, check. It's in the calendar. Yesterday is asking Samiksha's class. Check in the
Yes,
calendar.
Oh,
Of
okay,
yesterday.
it is in
Samiksha.
calendar.
Got
Okay.
attached in calendar.
So I don't know about.
No, just it's in the calendar. Yeah.
Yeah,
Okay.
it's in the calendar.
Can you share it, anyone? I cannot find it at all. Where is in the calendar?
Let me try.
Bro, you have to check in the calendar.
In the calendar, Google Drive, right?
Google
no,
Calendar.
Just Google Calendar. You will just click on the yesterday's session, and you will see a link to the PDF.
Okay. Thank you.
Okay, so we can continue. Okay. If you have any other queries, you can ask after the class, not now. Okay. So as we know, this is the exponential function where a is from 0 to 1, union 1 to infinity, right? So once I say this is a bijective function, that means we have a inverse for this exponential function, right? So what is the inverse for the exponential function? Anyone?
Logarithmic.
Yeah, right.
Log.
Yeah. So log is the inverse function of exponential function, right? So again, for log we have a base a and we can apply x then. So when a is 0 to 1, we have log ax as a inverse of a power x, right? And same for a greater than 1, right? So once I call it inverse, that means it will satisfy the property of a power x is equals to x, and this is equals to a power log a x is equals to a. right? That means composition of inverse function is identity function, right? For any a, for any a not equals to 1. Okay.
Ma'am, will you scroll up just, ma'am? Yeah, okay, ma'am.
So
what
composition of, that means if we have a function f, then composition of the function with the inverse function is the identity function. That means this property. Okay, so this is the property, and I'm just writing this one here. Okay, because logarithmic function is inverse of exponential function. Okay, so once we know that exponential function is the inverse of logarithmic function, that means the graph of the exponential function and graph of the logarithmic function will be symmetric with respect to the line x equals to y, right? Right. So this is the line x equals to y. When a is greater than 1, we know that the exponential function looks like that, right? And once we want the logarithmic function, and we know that it should be symmetric with respect to the line x equals to y, that means we can get some idea about the logarithmic function, right? From this step, correct? So this will be
मेरा हो जाता है भाई.
Yes.
मेरा regular.
like that, right? So
पानी पिया कर. पानी पिया कर.
happening here.
बाटी ठीक नहीं था.
मैम ये कौन है? पानी
कोई
पीने के
पानी
लिए
पी
बोल
रहा
रहे
है।
हॉस्टल में मिला है, बाहर नहीं है. ऐसा ही रहेगा.
Who are they?
चूरमा ठीक था तो चूरमा डाल.
अच्छा, सुरमा भी डालना है?
हाँ. अबे हलवा थोड़ी है वो.
ओ भाई साहब.
स्पीकर बंद है
अरे ये
तो
कौन
ये
है?
माइक
मैम
हाँ भाई.
Can you please
स्पीकर ऑन
mute
करो,
yourself?
माइक बंद करो।
हलवा
भाई हलवा बन गया, अब चलो बंद करो
फेंक दिया
माइक।
तुम.
अरे भाई
खाना
बंद करो माइक।
है दोस्त
पूरी बना के
भाई.
बंद करिए।
Who are these?
Ma'am, these are spammers. They comes and entertain us always.
Okay, it's good to have some entertainers around us.
Yes.
I think you are not yet clearly last word. I think you are not yet clearly last word. That is clear.
I don't want to hurt him even. Okay, so this is the graph of the logarithmic function, and this is the graph of the exponential function when a is greater than 1. Okay, so obviously we can see from the graph that like when a is 1, again the greater than 1, again the function logarithmic function is also increasing function, right? Okay.
Yes.
Yeah. So when a is 0 to 1, then again we can draw the graph of exponential function and logarithmic function, right? So we know that when a is 0 to 1, then the exponential function is a decreasing function, and the graph of the exponential function looks like that, right? And after looking at the graph of exponential function, we can immediately draw the graph of logarithmic functions too, right? Which will be nothing but the graph which is symmetric with respect to the line x equals to y. That means it will be something like that, right? Which is again decreasing, right? So when a is 0 to 1, exponential function, logarithmic function, both are decreasing. When a is greater than 1, exponential function and logarithmic function both are increasing. Okay.
inverse, then why in both the situations they are
Can you
inverse?
bit lit louder? I cannot hear you.
Ma'am, why is this, if it is symmetry, ma'am, it is inverse logarithm function,
Yeah, this is a
then
rule. I mean, once a function is like, once two functions are inverse of each other, that means their graph will be symmetric with respect to the line. Because, okay, so let me just describe it. Why is it so? Because what we know, the graph of a function, we can represent it as gamma x, and which is like fx comma fx, right?
Yes, ma'am.
The movement of this type of points is graph of a function, right? So what is graph of f inverse s? So again, it will be x comma f inverse x, right? Correct. So these are the points. That means x is from the codomain, actually range of f, and this is from the domain of f, right? So we can rewrite this thing as, again, some x, where x is belongs to domain of x, and fx, sorry, fx comma x, right? So if we collect this type of function, and if you like apply f inverse to this type of function, then it will become x comma f inverse x, right? So you can see this is just the symmetry, right? We know the symmetry property. The first graph of f is x comma fx, and graph of f inverse x is fx comma x, right? So this is basically symmetry. All the points are symmetry, hence the graph will also look like symmetry with respect to the line x equals to y. Okay, any doubt?
Ma'am, will you explain the logarithmic function in second case,
Yes,
ma'am?
ma'am.
0 less than a less than
Ma'am,
1.
Yes.
ma'am,
Ma'am, can
please
you
write this
explain
gamma
that
function.
again?
Yeah, the inverse, like the symmetry we didn't understand.
Okay. So the logarithmic function, when as a we can draw the graph of the logarithmic function as a inverse of the exponential function, right? So because this is the exponential function, and the logarithmic function is this one, so we can see that this is symmetry with respect to the line x equals to y, right? So using the graph of exponential function, we can draw the graph of logarithmic functions, right? So this is clear. And now, why is it so? I mean, why two function, if they are invertible, why their graph is symmetric with respect to the line x equals to y? So graph of f, let me denote it with gamma f. This is graph of x, okay? Graph of f. So this is collection of all these element x comma fx, right? Where x belongs to the domain, that we all know, right? So what will be the graph of f inverse? So this is again f comma f inverse x, right? Where x belongs to the domain of f inverse, and domain of f inverse is nothing but range of f, right? Right? Is it fine up to now? We are calculating, the graph of f inverse, and graph of f inverse is this. X belongs to domain of f inverse means range of f. Now once f belongs to range of f, so we can write x equals to some f of y, right? Where y belongs to domain of f, correct? Right? Because x belongs to range of f, so we can write f equals to f of y, where y belongs to domain of f. Now if we put the value here, so we will get f of y comma f inverse of f of y, right? So in the next line, we can write it where y belongs to domain of f, right? Now the set becomes this. Now in the next line, we can simplify and we can write f of y comma y, right? Y belongs to domain of f. Okay, so this point are now symmetric of this type of points. That is why the graph also looks symmetric. Is it fine or any doubt?
So, ma'am, the rule was that when we are having two inverse functions, then they will be symmetric to symmetric.
With respect to the line x equals to y. Yeah. Okay. So once we know the graph of some function, we can draw the graph of their inverse function too, which will be clean, just symmetric with respect to the line. Okay.
Ma'am, can you explain what is symmetry with respect to origin?
Symmetry means, I mean, it will be if you just flip the graph with respect to the line.
No,
Then it
origin,
will be
ma'am.
same.
Odd functions are symmetric about origin. Could you give an example? Like,
Symmetric with respect to origin.
yes,
Like
ma'am.
you should have a line when you are saying about symmetry.
Okay, ma'am.
Yeah.
Ma'am, one more question. This in graph theory, ma'am, in week 10, in one of the, what do you call, in breadth search in BFS and DFS, they'll give a graph and they'll ask if this graph can, which of the following graphs are the BFS of this graph? How to do those questions, ma'am? Could you elaborate?
Let's not go into this thing right now because
Ma'am, just in a minute, can you explain quickly, ma'am?
no,
Because
see, I will try to cover this, but after the end of the class, because let us now first focus on the portion which is today's syllabus, right? After that, we can do that. Yesterday, you had the graph theory class, no? You didn't ask this type of thing yesterday.
no, ma'am, sorry, I couldn't attend the class. Ma'am, after an hour, can I ask the same question, if possible?
Yeah, once let us finish the portion which is intended to finish today. Then if there is a time, I can discuss about it. Okay?
Ma'am, when will this class extend till? Could you give me an exact time?
Up to 10:30 maybe.
After, okay, ma'am.
Or you can watch the whole lecture of yesterday's on YouTube.
Yeah, that is one possible way. You can watch the whole lecture so that you can get the answer of your question.
Sure,
Okay?
ma'am. Okay, thank you.
Yeah. Okay. So that is this is the reason why a graph of a inverse function of some function is symmetry with respect to the line x equals to y. Okay. So we can just note one, exponential function is fx equals to a power x, where this a is r positive minus 1, okay, and which is invertible, and inverse is logarithmic function, and that here the domain was from r to 0 infinity, and because logarithmic function is inverse of exponential function, so range of exponential function is now the domain of logarithmic function, and domain of exponential function now become range of logarithmic function, right?
Yes.
Yeah. So these are the things we have. Okay, now we had some formulas about exponential function and logarithmic function, which are not covering right now, as I wish I know I'm considering you all know about this theorems. So we can solve some problem using this.
Ma'am,
Yes.
ma'am, for existing inverse, the function should be bijective.
Yes.
And
First,
ma'am, but the trigonometric functions are not bijective.
why? They are bijective in their range and codomain. Like once you are saying
We
a
have to
function
restrict
is,
the codomain.
yes. So once you are saying the function is bijective, that means you always have to mention the domain and range. Okay. Once you restrict the codomain, the function will become bijective. trigonometric functions are bijective, but in their respective domain and codomain. If you take the codomain as whole real number, then it will not be bijective. But if you restrict the codomain to +1, -1 to +1, then it will become bijective. Okay.
Okay,
Ma'am,
thank you.
another question. Is it compulsory to a function to be 1, 1 or injective for having inverse?
I mean, what are you saying? I mean,
No.
Yes, of course. It should be bijective, then
okay,
only
for
it's possible
any
to
function
inverse.
you are saying.
Yes,
1,
ma'am.
1
For
plus
any.
1, 2 is
Okay, yeah,
necessary.
it's possible. It's
Otherwise,
possible.
inverse
So
is not
you
a
can,
function.
yeah. So you can take any function which is maybe not bijective. Then if you just restrict the domain and codomain, then you can fix at least one domain and range so that the function will become bijective in its
No, ma'am. I'm asking about injectivity, ma'am. Is it compulsory to have a function injectivity compulsory so that it is having
yeah,
inverse?
again it's on the domain. I mean, if you have
Okay,
a
ma'am.
function and if it may not be injective, but if you restrict the domain, then in some chosen domain the function may be injective. Just for example, suppose you have the parabola. We know parabola is not injective, right? But
Yes, ma'am.
if we fix the domain to this, I mean from vertex to positive infinity, then this portion of the parabola, like this portion of the parabola is our new function, right? So we had a
we have to
parabola.
make injective anyhow to make it bijective.
Yeah, obviously, like in order to get a bijective function, it should be injective and it should be surjective, right? So if you want to like if you have any function which is not even injective, you can choose some domain so that it will become injective in that particular domain. Okay.
Ma'am.
Okay, ma'am. I'm having a question about it in graded assignment. No problem. We'll discuss it later.
Okay.
Please continue with the class, ma'am.
Yeah.
Ma'am, one small question. Suppose in the question paper it is given is sin x bijective without telling us what is the codomain of the range. So what will I write? It is bijective, or will I say where is the codomain or something?
Okay, whenever it is about is the function bijective or not, they will always mention the range and codomain. Without looking at the range at the codomain, you cannot say the function as bijective. But sometimes because trigonometric functions, exponential, these are some standard function, so we know the range and domain of the function, right? So whenever we are saying the function is bijective, we automatically consider the range and domain as per the rules, like the range as -1 to +1, not the whole real line.
Okay.
Yeah.
Ma'am, the parabola is onto function if we restrict the range.
Yeah,
domain.
obviously, yes. So parabola will be onto function if you restrict the domain. Sorry, codomain. Okay. The thing is, in order to make some function 1, 1, you have to restrict the domain. And in order to make some function on 2, you have to restrict the codomain. Okay. Clear?
Yes, clear.
Okay. Suppose we have example like okay, so for this type of example, suppose we want to solve the equation like the value of x. We have to find the value of x. I'm giving you 2 minutes. Just try to solve and let me know what is the possible value of x.
Ma'am, what's the question?
You have the given equation, and from this equation you have to solve the equation and you have to find the value of x.
Ma'am, the value of x lies between 1 to infinity.
I mean, you have to find the specific value.
Ma'am, can you take logarithmic?
You can use anything. I mean, whatever you know, whatever tools you have, you can use them, and you have to find the root of the equation. That means the
Ma'am,
value of x.
0.
0. Okay. Anything else?
No, ma'am, because the root is coming negative. E to the power x is equals to -3.
Yes, ma'am, -3.
Okay.
Yes.
Does
So
not
Yes, ma'am.
exist.
Same.
function cannot be
Okay.
negative.
Okay, let us take this.
Log 3.
Yeah, right. So this is
Yes,
the
ma'am.
this is the typical process. I wanted to know just if you know or not. So we will just typically use this notation and
Ma'am,
we
we
will
can
solve.
assume e power x
Ma'am,
as
actually
range.
it's ln3, ma'am, not log3.
Yeah, like at natural base, right?
Yes.
Minus ln3.
So e power x will
No,
be
direct ln3.
e power x
Okay.
minus 3 whole square will be equals to 0, right? So e power x will be equals 3. That means x will be ln 3, right?
Yes,
Hello,
ma'am.
hello, ma'am. How it is -3? It is +3 now. You have changed the sign.
Yeah, I have changed the sign plus 6 to minus 6.
Yeah, if we do
Okay,
not
okay.
change the sign, then we cannot
Then you
put it as
cannot
ln.
Then
find
does not
any root.
exist.
Yeah,
Yes,
then
ma'am.
there is
That's
no solution. That means this line, if there was a plus, this line we will not cut the x-axis. Okay. Okay. Then we learned about sequence, right? So what is the definition of sequence? Anyone knows? What is a sequence?
Sequence of same sequence and it is in any order. Different.
Can you be little louder?
Natural numbers plotted to real numbers. Is it?
Sequence any number with same distance between them and in order.
Okay. That means a sequence is basically kind of function from natural number to real number, right? So once we know what a sequence is, then we have like once we have a function, we have limit of the function. So we have limit of a sequence. Okay.
Ma'am, in the sequence,
Mhm.
when I am practicing the question, I am getting some question from APGP.
APGP, yeah. Maybe you
Yeah.
have to sometime use the formulas for APGP.
so,
When
ma'am, the formula will be given now if we have to use that.
No, the formula will not be given.
so ma'am, we have to again read it from the artificial mind
Revise. We have to revise the APGP
Yeah,
from
you have
class 11, 12
to.
book.
Yeah, it's about just 2 to 3 formulas, na?
Yes, ma'am.
Okay,
And
ma'am. Then please
some
revise them
formulas
in this
are
session
already
only.
discussed in the statics section. GP
Yeah, you
formula
can
is already.
मैम
just
एक बार
take.
आप एक काम कीजिए, आप रिवाइज करवा दीजिए फॉर्मूला को.
Okay. So limit of a sequence means we know we can, if we have a sequence, if n equals to an, so limit of a sequence we typically denote as limit n tending to infinity an, right? So if the limit is something finite, if the limit is finite, suppose limit equals to L, if L is finite, then we say that the sequence is convergent, right? Correct? And if the sequence is not convergent, then we say that the sequence is divergent, right? Then we say the sequence is divergent, right?
When will be the sequence is divergent? What is the condition?
That
Infinite.
means if, yeah, so if the sequence is not convergent,
When
then
L is
you can,
infinite.
also you can consider the case of L doesn't exist. I mean, for this type of sequence, suppose -1 + 1 -1 + 1. So for this type of sequence, you cannot find any specific L, right? for example, suppose you have sin n, okay, limit n tending to infinity sin n. This doesn't exist, right? Because you don't know. It can be anything between -1 to +1, right? But you never know what is the exact number, right? So this type of for this type of sequence, limit doesn't exist, okay? So this type of cases are also under the case of divergence, okay? That means if the limit, if you can find the limit, and if the limit is something finite, then we can say that the function is convergent. If this is not the case, I mean, if the function is not convergent, then immediately conclude the function is divergent, okay? That means the sequence is divergent, okay?
Yes, ma'am.
Yeah. Then we have subsequences. So subsequences, we can say, yes.
Ma'am, will you tell the examples for them?
Yeah, yes. So convergence sequence, we have a natural example in our mind, 1 by n. This is convergent to 0. Or 1 plus maybe -1 power n by n, which is convergent to 1, right? So this type of sequences are example of convergent sequence, and this type of sequences are example of divergent sequence, okay?
Yes.
Ma'am, once again show the convergent one.
1 by n, this is one example, and 1 plus 1 power n by n. This is one example which is converging to 1, okay? That means for this type of sequences,
Okay, ma'am.
Ma'am, can I
right?
know how it is convergent to 1, the second case?
It's going to 0, not 0 now.
So
1 by
n tending to infinity, 1 plus -1 power n by n, right? So we can write it as 1 plus limit n power infinity -1 by n by n, right?
This term will be 0.
Yeah. So this is something finite, right? And this is tending to 0 when n is tending to infinity. So the total term will be tending to 0. So it is 1 plus 0, that means 1. Okay? Yeah. And for this type of cases, or if you take just simply an equals to n, this is converges to infinity, right? So for this type of cases, you can say the sequence is divergent. Okay? So these are some example of convergent and divergent sequences. Okay? Then we know about subsequences. So a subsequence is, you can consider as a subset of the range set of a sequence. That means you can collect some entries from the sequence in some order, and then it will be a subsequence. That means subsequence is a subset of the sequence, and it is a sequence. Okay. Okay, so it have to follow the definition of sequence first of all, and secondly, it will be a sub collection of the range set of the given sequence. Okay, just for example, if you have simply n, that means 1, 2, 3, and so on. So you can collect the even terms, that means 2, 4, 6. So this is an example of subsequence. Okay. You can collect the odd terms, that means 1, 3, and so on. This is an example of odd sequence. Okay, you can collect this type of term, that means 1, then 2, then 4, then 8. That means 2 power n. Okay, so this is another subsequence. What?
If we collect all of them,
I cannot hear you.
if we
Ma'am, his
collect all
voice
of
is
them,
very low.
Yeah, that is why I'm not able to hear you. Can you be little louder? I mean, otherwise.
I think that my voice is not clear because of I earbuds.
Okay, if you
not
have any
clear.
doubt, you can maybe write in the chat box, because I'm not able to hear you. Okay, so if you have
Yes,
this,
ma'am.
yeah. So if you have this sequence, then these three are examples of subsequences. Okay, you can form subsequence collecting some elements from the sequence. But suppose if you do this type of thing, and so this will not be a subsequence, right? Because here we are repeating elements, which is not possible. We cannot repeat elements. Okay, that means once we have one element here, I mean one
I just want to say that if we collect all of them, then what happens? Like this proper subset and
yeah, so you can again say it as improper subset, but yeah, there is no meaning. I mean, if you are defining something, that means you have some purpose, right?
yes, ma'am.
So if you take the whole set, it will be a subsequence. Like definition wise, you can call it a subsequence, but there is no meaning to do that, right?
Oh, okay.
Yeah. So this is not a subsequence. So we had an example of sequences, subsequences, and not subsequences. Okay. So what is the importance of subsequences? I mean, sometimes we may have some sequences which are little bit like tricky, right? For this type of sequences, we can part them in subsequences, and then we can find the limit of the sequence of all the subsequence. And the rule is, one rule is, if a sequence an is convergent, then all subsequences of the sequence will be convergent and converges to the same limit as an. Okay, that means if you have an is tending to L, that means suppose Bn is any subsequence of an, you can automatically imply that Bn is convergent.
Also tending towards L.
Yeah, right. So this is one theorem. Okay, and another remark, yeah, another remark you can take is if B1, B2, Bn1, B2, Bn2, Bnk. Suppose these are subsequences of an, okay, such that if you just union them, I mean they are disjoint, that means their intersection of B and K is phi, and union of B and K is equals to the set. That means the range set, I'm saying, okay, equals to the range set of A, and such that all the B and K are tending to same limit L, then we can imply that the sequence N will be tending to the same limit L. Okay, is the statement clear?
Can you repeat?
Okay, so we have here K different subsequences of the sequence N. Okay, so B1, B2, Bk, all are single subsequences. Okay, that means all are subsets of the range set of N. Okay, so all are subsequences such that they are disjoint. That means if you take any, like if you take intersection of any two of them, then it will be phi. Okay, and if you take the union of this set, then it will be the whole set. Okay, in one line you can say their subsequences such that they form a partition. Okay, this is the definition of partition, right? So union is the whole set N, and if all the subsequences are tending to a single limit L, for all k, that means all the subsequences are tending to the same limit L, then you can imply that the mother sequence also will be tending towards the same limit L. Okay.
So, ma'am, the first part you're saying all the subsequences intersect at nowhere. That's what it means, right?
Yes, right.
Okay.
So if you have some set of subsequences which are which follows these things, that means which doesn't intersect, if you union them, then you will find the main sequence and all of them will tending to same limit, then you can imply that the mother sequence is also tending to same limit. Okay. So
Ma'am, could you please give example?
yeah, this is what I'm doing. So for just simple example, for I took this one, right? So we know this sequence is tending to 0, right? So we can prove this using this remark.
1, ma'am.
Sorry, yeah, right. Thank you. So this is tending to 1, right? So we can use this. So this is n. Now we can define two subsequences, right? One a to n, which is 1 plus 1 over 2n, right? And one is a 2n minus 1, which is again 1 minus 1 over 2n minus 1, right? These two are subsequences. And if you just notice, the intersection is 5, right? Right? The intersection is 5. And if you union, then you will get the whole sequence an, right? Correct?
Yeah.
And both
Hello,
the
ma'am, please
sequences,
explain that AM minus 1 part.
these are two subsequences of this sequence. A to n means we are collecting the even terms, and a to n minus 1 means we are collecting the odd terms. Okay.
Ma'am, minus 1 to the power, it's n.
Minus n to the power something odd. That means it will be minus 1, right? And minus 1 to the power something even mean it will be plus 1. That is why I took this. Okay.
Okay.
Yeah. Now you can notice that these two sequences are disjoint, right? Their intersection is 5 and their union is the whole set, and both the sequences tends to 1, right? So from here also we can imply that the sequence an will be tending to 1. Okay, clear?
Yeah, but if it is both the sequence are different,
Then we can
then
directly say that the sequence is divergent.
okay, got it.
Note, if there is any two subsequence of a sequence which are tending to different limit, then imply the sequence
It's divergent.
Yeah, right.
And how will we know that up to what limit it is tending to?
You have to calculate the limit, no? That is what you have to do everywhere. So once, if you have something complicated, and you can simplify them using the subsequence. This is the key why we use the subsequences even. Okay. And
Ma'am?
also, yes.
Ma'am, in this example, we don't know, right, what an goes to, where an goes to, sorry. And by the using of subsequences,
Yeah.
we know where they are going, like
Yes.
tending towards 1, and we
Yes.
come to the conclusion that an is also equals to 1, right?
Yes, right.
Ma'am, I have one silly doubt, like why the union is an, like, can you please solve that?
Why the union is an?
Yeah.
So this sequence means what? It will consist only those terms, na? Like in this first sequence, we are collecting all the even terms of the sequence, and in the second subsequence, we are collecting all the odd terms of the sequence. So now if
Okay,
you
ma'am.
merge them, it will be the whole sequence, right?
Yes, yes, ma'am. Got it.
So typically you have to check even terms of the sequence and odd terms of the sequence. That means you can part a sequence with two different subsequence consisting of even terms and odd terms. Okay. Then you can apply these formulas to prove it either convergent or divergent, both. Okay.
And when they are -1 to the power n, right?
Yes, -1 to the power n. Now, once we have even and odd, we can specify that -1, right? If we have something even, then the -1 power n will be +1, right? And if we have specifically odd, then this -1 power n will be specifically -1, right? That
Yes,
is
ma'am. Got it.
yeah. That is why we need this type of thing. Okay. Okay, so another example we can solve is, suppose an equals some 9n power cube plus n square minus 1 by cube plus 4n. So I have already taught you how to solve this type of problem. So I'm expecting you can solve. Just let me know the answer. I mean,
9.
Ma'am, a
9
small
is the answer.
correct.
Ma'am,
ma'am,
answer
a
is
small
9.
okay. Ma'am,
Ma'am,
if there is in numerator, if there is plus 5n power 4, then what
5n power
in
4.
numerator? Yeah,
Then
in
0.
numerator.
Then 0.
Then 0.
0. 1 by infinity,
If
what? 0.
okay, if the total degree in the numerator is greater than the above one, then denominator, then it's greater than the above one, then it will be always tending to 0, because 1 by infinity is tending to 0, right?
Yes.
I'm asking
Anji,
it
ma'am.
in numerator, ma'am.
Yeah, if it is in the numerator, then it will be tending to infinity.
Infinity does not exist.
That means it will be
Ma'am, could you
divergent.
please repeat? If the degree of the denominator is greater than the numerator.
Okay, so let me write it again as Riemann.
Ma'am, please solve this question. I think I didn't join that class.
So why did my notes? Okay.
Ma'am, how it's divergent actually?
Okay. Just wait. Let us solve this. What was the question? 9n cube plus 3n squared minus 1 over n
n
cube
plus 4n.
4n. It was the question, right? So first, let us see how can we solve this type of question. Once we have this type of question, you have to take the term with maximum degree and then you have to cancel it. Okay. So if you just take this term, so you will get 9 plus 3 by n minus 1 by n cube by 1 plus 4 by n square, right? Now, if I take limit n tending to infinity, then this term, and this term, this three term will be tending to 0, right? So you will get the answer as tending to 9. Yes.
How this step came?
Which one? We are
And
taking
this last
n
one?
cube. We are taking n cube as common from both numerator and denominator. Okay.
Okay, so highest degree will be taken.
Yes, the highest degree will be taken. Then you have to cancel them out from the both side. Then take the limit, and 1 by infinity means the limit will be tending to 0.
Ma'am, I have a doubt, ma'am.
Ma'am,
Will you explain if we keep n power 4 in the numerator, why it tends to 0
yes.
or something infinity? Yeah.
मैम कब डाइवर्जेंट होगा कब कन्वर्जेंट होगा ये इसमें थोड़ा कंफ्यूजन हो रहा है मेरा.
Divergent means you will not get any finite limit or any limit. If there is any finite limit, that means this sequence is convergent. So in this case, we are getting the limit as 9. That means the sequence is convergent. Okay, convergent and converges to 9.
If I get 0, then
0 is also a finite number, right? If you get 0, that means it is again. So suppose we have n. Yes.
Oh, if the limit is undefined, then it will be divergent.
Yes. If it is undefined, that means it can be infinity or it can be something doesn't exist.
अच्छा, convergent मतलब एक जगह दूर से आगे एक जगह मिलेगा सभी टर्म, और divergent मतलब फैल जाएगा.
Right. Correct.
Or we can say that apart from finite, if any answer came, then it's a divergent, right?
Yes, correct. Right.
Ma'am, will you go through that?
So suppose we have n cube plus 3n square minus some n power 4. That means the degree of numerator is something greater than degree of the denominator. Okay, so suppose this type of thing we have, then if you take n power cube and just take common, so we will get this type of thing, 3 by n minus n by 1 plus 4 over.
Ma'am, minus 1, n power 4. You are dividing.
We are taking n cube.
N cube common.
N cube.
But then you can't find out the limit.
No. Still
it will be divergent.
Still, that is what. Like if you take n power 4 also, then it will be divergent. Okay, let us compare them. Here I took n power cube as common, and let us take n power 4 as common. Then we will get n plus 3
So
by
we'll get minus 1 by 0.
minus 1 by n cube maximum we can take common from here. So from here we will
get because we are
1
getting minus 1 as the answer. That's why.
No, like still if you cancel them out, there will be a n numerator, right?
Infinity will be the answer.
Yes. Now if n tending to infinity, then this will be tending to infinity. If you choose this way, again this will be tending to infinity. This is infinity into some minus 1, right? Actually minus infinity, not infinity. Right?
So ma'am,
Excuse me, ma'am.
please show the previous problem and compare this one with this one.
Okay. See, here in that case, these two limits were tending to 0. And this was also only finite. And in the in this portion, this limit was tending to 0 and this was only finite, right? So you will get 9 plus 0 by 1 plus 0. That is 9, right? But here, if you compare the limit, this will be tending to 9 plus this will be tending to 0. This will be tending to infinity by 1 plus 0. So this all over term is tending to 9 minus infinity, which is minus infinity, right?
Then 3 to the power n is infinity. N is infinity now. That's why it's 0.
Yes, because we have one n left in the numerator.
Yes, yes.
So we have to take the limit as infinity. Okay. So if the degree of
Excuse me, ma'am.
Yes.
Suppose denominator highest degree.
Numerator highest degree or denominator? What?
Denominator.
Okay, that is what I'm writing as a remark.
Then this solution only for this type of question. Huh?
Yeah.
If we have to find
yes,
value,
right.
then it's not.
Yeah. So if you can find a finite limit.
So ma'am, कब ऐसा होगा कि न्यूमरेटर का डिग्री अगर डिनोमिनेटर से ज्यादा है तो वो कन्वर्जेंट होगा या डाइवर्जेंट?
Divergent. That is what I'm writing. If the degree of numerator is greater than the degree of denominator, then the sequence will be divergent. Okay.
Only if limit is tending to infinity, right, ma'am?
Yeah, that means the limit will be tending to infinity or minus infinity. Okay. For this type of cases only.
Ma'am, what if degree of numerator less than degree of denominator?
Yeah, then the sequence will be convergent to 0.
Ma'am, I'm having a question of the same format, which is tending to 0.
Yes.
Could I orally say it?
Yeah, sure.
Yeah. Limit
अगर मैम
extend. Yeah.
अगर मैम दोनों का डिग्री सेम हो गया तो
Then you can
Then you
find
will
the
get a
limit.
finite answer.
Yeah. Other than
ओके
this.
ओके
Okay. Then you will
वैसे
get
सेम
a
नहीं होगा.
no same
क्यों नहीं
was
होगा, होने को कुछ भी हो सकता है.
okay. See, it can be same, it can be greater than, it can be less than. If the degree of numerator is greater, then the sequence will be divergent. If the degree of numerator is lesser, then the sequence will be convergent and converges to 0. And if they are equal, then you have to take them out and you have to cancel the term. Then you have to find the finite limit. Okay.
Ma'am, one small question. The question is a to the power x, a to the power x divided by factorial x tends to infinity. Is there some limit, standard limit for this, or
Yes,
actually?
this will be tending to infinity.
No, ma'am, it cannot tend to infinity. Actually, this I have in the statistics class. So it is lambda to the power x, e to the power minus lambda by x factorial for Poisson variable. So actually,
One lambda to the power x.
e to the power minus lambda
Minus lambda. Okay.
by x factorial. X factorial. X can vary from 0 to infinity.
Here this will not be infinite because you have e to the power minus lambda, and lambda is not variable here, but here x is variable, and exponential function is most fast growing function. And once you have the most fast growing function in the numerator, then the limit will always be tending to infinity. You can apply the L'Hopital rule even. So you will get a power x here always, but after certain term, this will be a constant.
Okay. So
like we can use the logarithmic. What you were saying something?
Ma'am, could you also solve this one, a to the power x?
Yeah. So okay.
Ma'am, I have one question. That if degree of denominator is greater than degree of numerator, then sequence is convergent and the limit is 0, or it is 0. Sequence is 0.
Limit is 0. It's convergent to 0.
Convergent to 0 means?
Ma'am, this is only for infinity case,
limit.
right? It's not for general case, right?
Yeah, it's only for this type of case when you have like polynomials in both the numerator and denominator.
Ma'am, I'm having a question where could I limit extends to 0? In the numerator, 9x power 4 plus 8x power 6 plus plus 5e power minus 3 by x power 4. Minus 3 by x power divided by minus 3 divided by x power 4. Divided by whole the denominator x power 4. Limit extends to 0.
Yeah, divided by what? Like
X power 4.
Oh, that
Just
means
x power.
not this.
No, that is there. That is there.
Okay, like both.
Yeah, both are there.
Minus 3 by
x power 4.
Whole by x power 4.
Yes, ma'am. Limit extend to 0.
Apply the L'Hopital rule.
Yeah. So if you
because
can...
the numerator is 0 by 0 format.
No. If you put 0 here, okay, yes, right. So if you put 0 here, it will become e power minus infinity, which is going to 0, and this term will be 0, right? So you have to apply the L'Hopital rule. In that case, also we have one thing to do, like limit into infinity. You can separate them. 9 plus 8x squared. Okay. 5 limit for the simplicity. Okay.
Ma'am, e to the power minus infinity is 1, na?
Yes. No. E
Zero,
power
zero.
minus infinity is 0.
0, yes.
Okay.
Can we know the
So
reason why e power minus infinity is 0?
denominator.
E
Graph,
power
graph,
minus infinity, you can check the graph, right?
graph.
The graph is like that.
Ma'am, can you explain the 9 plus 8x square in the bracket?
Yeah, I just separated them, and you can take this portion, then divide it with x power 4. Then again with this portion. Okay.
Okay. We divided it by x by 4. Okay.
Yeah. So this will become now 9 plus this one. Now you have to apply L'Hopital rule. That means you have to derive all the forms, right? So it will be 5 extending to 0. Then you can compute the derivative of this term. Also, one thing you can do is you can write it as like this, 3 by x power 4.
Hello, ma'am, is the answer infinity?
Okay, we can check it, right?
Answer is 9, ma'am.
9.
That means this will be, yes, the answer is 9, because this will be now tending to infinity, right?
Yes, ma'am.
E power infinity. So, and this is after some term, you can cancel them out, because once you will derivative this 1 by x power 4, you have to again derivative this term too, right? So you can cancel them out. Am I clear?
So e power infinity is one number.
No, not 1. This is
infinity.
infinity. Yeah. So if I derive this term x power 4, let us write it with this whole dash. Okay. So once we have this, we have to derive this also. Then e power 3 by x to the power 4. Right? This is after the derivation.
Ma'am, x tends to 0 or infinity?
Oh, x tends to 0 was the answer, right? Okay, so if x tends to 0, then it will be, yes, then 1, like 3 by x power 4 will be tending to infinity, right?
Okay,
That
ma'am, let
means
me
e
check
power
the
infinity.
question. Let me check the question.
Sure.
Yes, ma'am. X tends to 0.
Yes, so we can cancel this two term out, then we will get 5 limit extending to infinity 1 by 3 into e power minus 3 by x power 4, right? Now once x is tending to 0, then 3 by x power 4 will be tending to infinity, right? Hence e power 3 by x power 4 will be tending to infinity, right? So we will get 1 over infinity, right? That means 0. That means 9 plus 0. So the answer will be tending to 9. Okay. Any doubt?
Ma'am, from last to the third step, ma'am, I think.
This one?
The upper one.
This one?
Yes, ma'am. How did it come, ma'am? Like,
So
how
you
it comes
have to
from the previous one?
apply the L'Hopital rule. This is in infinity by infinity form, right? So we
Yes.
will we'll calculate the derivative of this term, which I denote with 1 by x power 4 dash. Okay.
Yes, ma'am.
And again, you have to calculate the derivative of this term, right?
Okay.
What is this? Now you can cancel this two term out, right?
Yeah. Yes.
Okay. Then in the next step you have this one. Then you can follow this steps. So this will be tending to infinity. That means 1 over infinity, right? So it will be tending to 0.
Okay, ma'am. Thank you. I got it.
Yeah. Okay. So
Ma'am, one thing.
Excuse me, ma'am.
Hmm.
Hello.
Ma'am,
Yes.
little bit scroll up.
One
I
question,
want to
ma'am.
note down the question.
Excuse me, ma'am. One question, ma'am. Hello.
I'm listening to you. Yes.
Yeah, limit x tends to 0.
Limit extends to 0.
Sine pi by 2
Sine pi by 2
minus 1 upon root under 1 minus x square
upon
Under root?
no, yeah, under root 1 minus x square upon n divided by
N?
no, just whole divided by,
Okay, like that.
yeah, tan 2 pi by 3.
2 pi by 3.
Yeah.
Bro, from where have you got this question, may I know?
Not just a knowledge for this question.
This is the question.
Yeah.
Okay.
He's from class 12, I think.
Yeah, I mean,
Hello, ma'am. We simply need to put 0 in the
yeah.
place of x, and
So
everything is
if
there.
you put 0, so you will get 0 by 0 form. Then you
No,
have
ma'am. How 0 by 0?
Oh no, sorry. 2
Sin pi by
There
2
is no
man
x.
sin pi by
Sin
2
pi by
180
2,
by
ma'am.
divided by 2.
Wait.
Ma'am, it will be sin pi by 2 minus 1 divided by tan 2 pi by 3 answer.
So
Yeah, you can take this.
sin pi by 2 will be 1.
Yeah, 0 by 0. Sorry, 0 by
1 by infinity.
1 minus 1, right?
1 minus 1.
And what is sine 2 pi by 3? 280 by 3, right?
Tan 2 pi by 3.
Sorry, tan 2 pi by 3 means 60. That means tan 1.
कौन से quadrant में जा रहे हैं देखिए?
tan 120, ma'am.
Tan 120. Now, what is the value of tan 120?
All sin 10 cos rule third quadrant positive आएगा ये.
हाँ, like it is positive. And what is the value?
Second quadrant. हाँ, second नहीं negative
I
आएगा.
mean,
Second
negative
quadrant.
आएगा.
Whatever it is something finite, right?
Yes, ma'am. Yeah, it's something finite.
Let me write it.
Madam.
So this will be 0, no?
Yes, ma'am. You're right.
0.
Any other question?
Yes, ma'am. Yes, ma'am. I'm telling, when can we apply the L'Hospital's rule and when we cannot apply the?
If you have some 0 by 0 form or infinity by infinity or minus infinity by minus infinity, like plus minus infinity by plus minus infinity, this type of form.
If 0 by infinity form?
No, 0 by infinity form is not defined. I mean, no, sorry. 0 by infinity means 0. 0 into 1 over infinity. 0 into 0 is 0.
Or infinity by 0. It's
Infinity by 0 is not defined.
Okay.
Something by 0 is not defined.
Yes.
Yes.
Infinity by 0 is not defined, but 0 by infinity is 0. Okay. And if you have undetermined terms, that means 0 by 0 or infinity by infinity or plus minus infinity by plus minus infinity, then you can apply the L'Hospital rule. Okay.
And if infinity to the power infinity or something is there?
This is also undefined. Infinity to the power
Ma'am,
infinity.
can we know what is L'Hospital rule for 0 by 0? We know.
So if you have some n tending to some limit a, extending to some a, if x by gx, okay. If a by ga is 0 by 0 or plus minus infinity by, you can take any combination in this form, then we can use L'Hospital rule. Okay, and the L'Hospital rule is this will be equals to limit extending to a f dash a, that means the derivative of f by g dash x. Okay, that means the derivative of g. Okay.
Okay. For infinity also we can take this, ma'am.
Yeah, this a can be anything, any limit. For any limit, we can take this. Okay.
Yes, ma'am. Thank you.
Anything else?
No, ma'am. Please move forward.
Okay, so we covered sequence, what a subsequence is, and how can we compute limit for some sequence, and when can we call a sequence as convergence sequence or divergent sequence, right? So we can do the same thing for functions, which is more general form of sequences. That is, and in the case of sequences, we used to take the limit as infinity, right? But for function, we can take the limit as anything. I mean, any a, where a belongs to real number. It can be infinity or minus infinity too. Okay. Whenever we are talking about sequence limit of a function, for limit of a function, we can take the limit as any number. And for sequences, this was particularly infinity and minus infinity. So this is the difference between limit of a function and limit of a sequence. Okay. And again, if we have a function, we denote the limit as at the point A as limit extending to A. Okay. If this is something finite, if L is something finite, then we used to call that the limit exists, then limit exists at A, right? If not, that means if L is not something finite, then limit doesn't exist, right? If not means L doesn't exist or L is not finite. Okay. This is the definition of limit of a function. Then we have continuity. So continuity means this L will be specifically f of a. That means limit extending to a, f of x, specifically f of a, right? If this holds, then we will say that the function is continuous at the point A. Otherwise, this is discontinuous at the point A. Okay. If this holds, then f is continuous at A otherwise it is discontinuous at A. Okay.
Ma'am, could you just zoom out once?
I cannot zoom in and zoom out.
Or could you go up then, just for 2 seconds?
Any doubt?
Ma'am, the
No, ma'am,
limit of
no doubt.
limit of a sequence and limit of a
Function.
I could not get it. Could you
Yes,
tell me?
ma'am.
Okay. So a limit of a sequence and limit of a functions, like the concept is actually same. Okay. But for sequence, we determine the limit only at infinity or only at infinity, right? But for function, we can determine the limit at any points, including infinity and minus infinity. Okay.
Yes, ma'am, you can move on.
So one remark, remark is when we are talking about continuity, then A must be in the set D. That means must be in the domain of A. Okay. Otherwise, we cannot define f of A, right?
Ma'am, it's not A, it's X, no?
No, A, the point A at which we are determining the like limit and continuity. This A. because we want f of a to be something defined, right? So a should be in the set of, like in the domain of f when we are talking about continuity, but when we are talking about limit, a may not be in the set, in the domain of f. We will see an example. Okay. Okay, so you have to take this thing in mind. Once you are talking about continuity of some point at some point, that point should be in the domain of a, otherwise we cannot talk about continuity, right? So if a is not in the domain of a, then we cannot guarantee that f of a will exist. In that case, the function will never be continuous, so we cannot even talk about continuity at that time. Okay, for example, if you take this function f of a equals to 1 by x, okay, so the domain of the function will be real line minus 0, right? And the range of the function is the real line, right? So we can talk about the limit at exist, I mean at a, okay, sorry, at a equals to 0. So limit extending to 0, 1 over x is something tending to, if something doesn't exist, right? Because if we take extending to 0 plus, then the function will be tending to positive infinity. If you take extending to 0 minus, then the function will be tending to negative infinity, right? In that case, left hand limit is not equals to the right hand limit, right? So you can imply that limit doesn't exist. Right? But at least you can talk about limit where the point is not in the domain, but you cannot talk about continuity when the point is not in the domain of f. Like in this example, for this function, you cannot talk about continuity of the function at the point 0. Okay, because when you are talking about continuity, you have to first ensure that the point should be in the domain of f. Okay, any doubt?
No, ma'am.
Okay, so again, this is the rule. Limit exists if and only if left hand limit equals to right hand limit, right?
Ma'am, so we need to first check the limit and then go for continuity.
Yes. Yes.
Okay.
So if a function continuity is something more than limit. So if a function is f is continuous, it will automatically imply that limit exists.
Ma'am, can you please explain the continuity in simple words?
Simple words means this is the definition. The limit should be equals to f of a. You can define the, you can compute the limit, right? If the limit is equals to f of a, then the function is continuous.
F of a क्या हो सकता है?
f of a means the functional value of a. That is why we need the
हाँ, वो तो
point
समझ
in the
गए.
domain, right?
लेकिन
So
limit.
you will get a finite point, right? That limit should be exactly equals to the finite point. If then only you can say that the function is continuous. Okay, for example, suppose okay, if I take some f of x equals to 1 plus mod x, okay, then what is the domain of this function?
All positive real number.
And what is the range?
R plus.
R plus 1.
No, R plus. I mean 0 to infinity.
R plus R.
Right?
1 to infinity.
Correct? This is the range
Yes, ma'am.
and domain
Yes,
of the function. Okay. Now suppose you want to talk about limit of the function at the point 0. So
And here in range, why can't we take 0?
1 plus.
Yeah, 1
There
plus 0
is-
is 1.
Then how will you get 0?
Can you
Is there
get
any
0?
possible way to get 0?
Yeah, okay.
Because 1 plus mod x, na?
Yeah. So mod x is always greater equals to 0, right? So
And
1
x
plus,
can take the value -1.
yeah, 1. Okay. That
What
is
is the,
why
what is the domain?
the domain is real number.
X can take the value -1.
Domain
It
is
will never
infinity to
give,
infinity,
it will
right?
never give -1.
Domain
real number.
domain can be anything.
हाँ
just
वही
not
वही
real number. Okay. Now we can break the function, right? When x is greater than 0, greater equals to 0, when x is less than 0, right? So when is x is greater equals to 0, we will find the function x plus 1, otherwise x minus 1, right? This is the rule. Using this, we can break the modulus function, right?
Yes, ma'am.
Yeah. Now suppose you have to check the limit of the function at the point 0. So what will be the limit?
One
1 plus
x.
x.
1, right?
It's 1.
So if we take from the positive side, we will get 1. 1 plus 0, that means 1. If you go from the negative side,
Then it also will
Then
be 1.
also 1.
So limit exists. RHL equal to LHL.
yeah, hence limit exists and limit is equals to 1, right?
Then f of 0 is equals to 1, so it is also
Yeah.
continuous.
Now f of 0 means the functional value. This is again 1. This is equals to the limit. Then the function is continuous. Okay.
Continuous. Yes, ma'am.
Any other question do we have in your mind?
तो मैम f of 0 के लिए 1 होना चाहिए उसी के साथ साथ तभी कंटिन्यूअस होगा.
Yeah, that means this should be equals to the limit.
अगर मैं ऐसा ऐसा करता कि 2 plus x and 1 2 minus x, then
Masumdar, sorry to interrupt. So if you're speaking in English now, so everyone understand. Otherwise,
Yes.
what we
Yeah,
Okay,
what we
okay.
are
just
speaking,
try to
what we are
continue in
speaking,
English.
so we are
if
listening.
if I take 2 plus x instead of 1 plus x and take 2 minus x instead of 1 minus x, then
The
Then the
answer is
limit
2.
will become 2, na? So
2.
this
And f of 0 is also 2.
then f of 0 will be 2.
Yeah.
Yeah.
Okay.
Ma'am, f is continuous, but it's not differentiable at 0, right? That's
Yeah.
what we can
Yes,
say.
yes.
Okay.
Yes.
Yeah.
Okay. So if this is fine, then we can move to some other example. Okay, you can take maybe again another example using modulus function, some x power 4 maybe minus mod x. If x is less than 0 and plus mod x. Okay. Now you have to calculate the limit and you have to comment whether the function is continuous or not.
What is it? X power 3 or what, ma'am? That one?
Yeah. One is x power 3 and one is x power 2.
X power 4.
Yeah. You don't even have to calculate it. You can comment just after seeing the function.
Ma'am, if x is greater than or equal to
Yes,
0.
limit exists and it is continuous.
Okay.
What is the limit?
Limit is 0.
Zero, right?
0 0.
And the function
Ma'am, it is
value will be-
continuous. Everything is 0.
Yeah, correct.
If you take only x instead of mod x, then it will not be continuous.
It's still continuous.
Ma'am, here we have to take
Yeah,
in
it's still
separate cases,
This
right?
mod x will be x, right? This is just a trick. I mean,
Yeah,
this
this
will
is
be plus and minus accordingly. Just you just change.
If it is 1, if we are taking x is less than 1 or greater than or equal to 1, then it will be changed, right, ma'am?
What?
Like if we take x is less than or less than 1 and x is greater than or equal to 1, like if we are changing the limit where we are checking.
Suppose x tends to
Okay.
x tends to 1.
Then we will check on 1, x tends to
Yeah.
1.
And if we
So
remove
you
the
have
mod
to
x,
check at
then
the point
it is
boundary
not
point.
limit.
No, ma'am. Then the limit value of right hand limit and left hand limit will not be same. if we take x tends to 2, x tends to 1.
I am not getting your points. What
Array, he just said to
Then
remove
the
the
limit
mod.
will not exist.
One,
Wait,
please.
wait, wait.
Only one.
He said to remove the mod. Then
Okay.
what will be
No,
happening?
no, if I change the limit, not the mod.
Okay.
If I
Limit.
change limit instead of x tends to 0, I take x tends to 1 or x tends to 2. Then
It will be a polynomial type of function at near 1. You can tend from
so
positive or
so
negative.
for ma'am continue for checking the limit is exist or not, or checking the equation of continuity,
You
it
have
is
to check
necessary
only at the
it is
boundary.
necessary to take x tends to 0, or we can take any real number.
No. See, at any point it will be continuous. Only you have to check at that point the function is breaking down.
So it will be mentioned in the question in which point I have to check.
Yeah, it
Okay.
will be mentioned in the question. Yes. So at the point 1, it will be automatically continuous, right? So at the point 1,
Yes.
we will get a polynomial function, correct? This, right? At the point 1, we will get that particular cubic polynomial function.
But instead of 1, if I take 2, then it will
Okay.
not be continuous.
Again, it will be the polynomial function, no?
Polynomial, but the value will be changed. Put 2 in place of x for both the conditions, then check.
What is limit extending to 2? X cube plus 2. This is 2 cube plus 2, right? And what is f of 2?
2. And then check
F of
right
2
hand limit.
also.
Right hand limit will be again
That-
same, no?
The condition is on 0,
No,
na?
you
Less than 0,
have
greater than 0.
you have taken x power 4 minus.
That is when x is less than 0.
That is when x is less than 0, right? When you are taking 2, that means you have to consider this domain only. I mean, for any positive number,
No, ma'am.
you have to
Ma'am, he's
consider
asking to change the limit, ma'am. We are checking for 0, right? He's asking in place of 0, please keep 2 in both cases.
Okay, that means you are saying if we fix the function like that,
Yes.
when x is less than 2,
Yeah. Now, yeah.
okay.
Now the limit won't exist, right? And it's not even continuous.
Yes, Manish, you are right.
Okay, yeah. In
Thank you,
that
Manish.
case, in that case, this is different. Yes. In that case, it is different. Okay. Do I need to solve this question or you can do?
No need, ma'am. Ma'am,
We can
so
do,
on,
need, ma'am. Move on.
it is discontinuous also, right? If limit is not existing.
Limit does not
If it
exist,
doesn't
then how
exist, then it
continuous?
will be automatically
Okay.
discontinuous.
Yeah. I just want to confirm. Yeah.
Okay. We can then move to differentiability, right?
yes, ma'am.
So what was the definition of differentiability? If I have a function and suppose I want to define the derivative of the function at the point 1, then what was the definition of the derivative? Mathematical definition?
Function defined at that point plus function defined at that point plus something upon
This, right?
Yeah, something like this. Yeah.
This was the definition for limit, correct?
Ma'am, is that in LHS f dash of A?
Yeah, right. Thank you for correcting me. So if this exists finitely,
This is kind of taking that small rectangle strip from the function. Am I correct?
What? What are you saying?
This f of h plus a minus f of a upon n is like taking the small rectangle strip.
Yeah. Yes, this is kind of same. That means if you have this is a and this is some a plus h, that means we are taking this 2 point, and when we are saying that h is tending to 0, that means this point will be moving towards this point slowly. Correct?
Yes, ma'am.
Yeah. And when this will be moving towards same point, so it will be very close to this point. If the limit exists, then we will find this line, right? And this line is called tangent line, right?
Yes, ma'am. Yes, ma'am.
And this tangent line, if you just extend the tangent line, at some point the tangent line will cut the x-axis, right? With the angle theta. This theta is called slope, and theta is equals to f dash of a is equals to tan theta, right? That we already know, right?
Yeah.
Okay. That means if tangent line exists for a function, we can imply that the function is differentiable. That means this limit exists finitely, right? And if this limit exists finitely, then we can say that the tangent line also exists, right?
Yes, ma'am.
Yeah.
If it's 0, then this is undefined, which line is horizontal. Sorry, vertical.
If it is 0, then the value will be 0. So no problem, right? If
Yeah,
it
if
is
Ma'am, he's telling
0,
for
then
90 degrees.
okay.
If theta is 90.
If the theta is 90, then it will be this. That means the tangent is the vertical line. Then tan 90 is nothing, like not defined, right?
Infinite.
Not
that's
defined.
why it's not defined.
Yeah.
Yeah, bro.
90 is not defined. So this will not be defined. That means if the tangent is vertical line, then at that point the function will not be differentiable. Okay.
Yes, ma'am. Yes, ma'am.
Okay. We can work with the last problem for differentiability. So again, same problem, x power 4 minus mod x when x is less than 0, and x cube plus mod x when x is greater or equals to 0. So you have to determine whether the function is differentiable or not at the point 0.
No, it is not.
No, ma'am, it is not differentiable.
Ma'am, will you explain?
So again, we have to first calculate the left hand limit and the right hand limit, right? So h tending to 0 minus f of h plus a minus f of a by h, right? So 0 minus means we will consider this function, right?
0 minus means from the left to right side.
Yeah. That means this portion of the domain, right?
Yeah.
So then the function will become x power 4 plus x, right? Correct? If I just omit the mod, then it will be x power 4 plus x.
Minus of minus becomes plus, right?
Yes, right. Minus of minus. Now we will put h plus a and a here. So our a is 0 here. That means it will be limit h tending to 0, h power 4 plus h minus 0, right? Over h. So this will be, you can take h as common, then we will get the limit
Ma'am,
as
A is
1.
the boundary point.
Mhm.
Ma'am, A is the boundary point.
A is the boundary point, yeah. Here we took a equals to 0. Okay.
Okay.
Specific.
And ma'am, in this, you have taken h tends to 0 minus, and the condition is x less than 10. So h and x are what? Synonymous or what? Same thing.
But can you repeat again?
Ma'am, in the limit, it is h tends to 0 minus, and you have taken the condition of x is less than 0. So x and h are same.
Yeah, I mean, when you are taking a variable, x is a variable, right? We are applying f over h. That means we are taking h as variable, right? So we have to
both are same,
from
x
this
and
domain,
h.
right?
X and h are same now then.
Yes. Huh.
Oh, okay.
Again, limit tends to 0 plus. Then that means we have to take this function.
Ma'am,
H.
will you tell that how it becomes 1?
Yeah. So you have to take h common from this portion. So you will get h cube plus 1. Then you just put 0 instead of h.
Yes, ma'am.
It will become h cube plus 1, right? Again, this will be h square plus 1. So both the left hand derivative and right hand derivative are equal. That means the function is differentiable at 0.
Yes.
Okay. That means this function is continuous, this function is differentiable, and limit exists at 0 for this function. Okay. Because if you just look at the function, this will be a polynomial function in the different interval, and at the point 0, it will take the value 0 from both right and left side.
Ma'am, if only mod x is there,
Yeah, mod x is there, but
at 0, could you say it is differentiable or not?
yeah, but there is, it's fine, there is mod x, but we define the function in such a way so that mod x is not a disturbance here.
Yes, ma'am. I'm asking only for mod x. Other questions.
Yes, yeah. If you have only mod x, then you
Yes, ma'am.
cannot define like anything, like any constant multiplication with mod x.
Ma'am, here in the left hand limit, how it is h power 4 plus h? It should be minus, right?
This is the function, no? When x is less than 0, this is the function. And x is less than 0 means mod x will become minus x. And minus of minus x means plus x, right? Okay.
Ma'am, here, don't we need to check functionality of limit, like f of 0 or something?
No, here we are talking about differentiability, na? That means
Yeah.
we need the limit as something finite.
Yes, ma'am.
For continuity, we need the limit exactly equals to f of 0. But for differentiability, we need the limit as something finite. That's it.
Yeah, okay, ma'am.
Okay, any other doubts? So if you have any constant multiplication
Excuse me,
plus
ma'am.
x,
Differentiability, formula, no? Suppose of u into v, u constant, v differentiability, and v constant, u differentiability.
yes, so this is the differentiation of multiplication of differentiation. This is
Yeah.
u v dash plus v u dash. Yes.
Ma'am, it is different from differentiability, right, ma'am? It is differentiation.
No, it is not different. I mean, this is a mathematical formula of differentiability, and based on these formulas, you have those formulas. Like you have now that a power n, I mean, a power n derivative means n, a power n minus 1, and so on. You had so many formulas, right? And those formulas you can prove using this mathematical theorem. But every time we cannot use this thing, right? So we need something simple so that we can do this thing quickly.
Yeah.
Right?
Yes, ma'am.
Excuse me, ma'am.
Yes.
Suppose u and v upon v square.
U
into v upon v square.
V square.
Yeah.
So it will be v u by v, right? Then you have to apply the quotient rule. So quotient
Yes.
rule is you have to first fix u. No, you have to first derivative u. V will be fixed. Then minus u fix derivative of v by
Divided by v square.
V square.
Right? This is the formula.
Yes.
So whenever you have multiplication and division where v is not equals to 0, obviously, so you can use the quotient rule and the multiplication rule of derivation to compute this thing. Okay.
Okay, ma'am. Thank you.
So
The previous question,
Mhm.
the mod x question is there, no?
Yeah.
For there, in x tends to 0,
Mhm.
you're saying that we are saying that there is a function continuous, it's fine.
Yeah.
But it is how we are saying this is differentiable.
Because
Because when it comes to mod x, there is
Yeah.
sharp edge will coming in the graph. If you plot in a Desmos, it's showing it's a sharp edge.
Okay, can you share the picture?
Yes, of course.
Sir, have you plotted only mod x or x power 4 minus mod x?
X power 4 minus mod x.
Yes.
It
Then
is
also it's
divided by. It is divided by or what? No, it is different function, right?
If this is different function now. So if you
Let me share
put
the
this
screenshot.
one, they will give you this function in whole interval. I mean, for x greater equals to 0 also they will give you this function. But this is not the case now. For x greater equals to 0, you have this function there.
So, ma'am, here for at that particular point, the derivative exists or not, we have to check the left-hand derivative and the right-hand derivative is
Yes.
equal or not.
Yes, if they are equal and something finite, that means limit exists finitely. That means the function will be differentiable, right?
They must be equal and must be finite.
Yes, like we are following the definition of limit, right? So instead of fx, we are taking this function. Okay, then what we know in the limit, that means if limit exists, means both the left hand limit and right hand limit exist and they are equal. And we are following the same thing here, right?
Yes, ma'am. If possible, just can you plot it over there because sharing the screenshot take time.
No, you
So,
just take
because
the
it is.
screenshot.
Okay, then I'll share.
Yeah, you just take the screenshot and share it. When you are putting the graph and the Desmos, you have to plot both the graphs.
Yeah, correct.
You can find the main graph.
Ma'am, you will continue the session until 10:30 or 11.
And no, not 11. Maybe 10:30. Let's see how much time we need. I don't think we need up to 11.
Only for 2 hours, no, ma'am, session.
Yeah, but we need some
Relaxation.
kind of explanation, right? You
No,
have
I just
queries.
shared it.
Okay. Is it? Yeah. So you can just check the blue portion. Okay. The red portion is for x less than 0, right? That means this portion of the function, right? Then after 0, we will take this portion.
Okay.
So,
So
though,
that it
ma'am,
is.
it is making a sharp turn, but we are not considering it.
Yeah, right. So this is
Done.
graph. Okay.
Done. Thank you.
Ma'am, could you explain for the blue one? One second. For the blue one, how is it going?
See, the red graph, this is for x less than 0, right?
Yes, ma'am.
And this was for x greater equals to 0, right? So the red graph is for this domain, right? And the blue graph is from this domain, right? So let us just redraw it. So it will be this up to 0. And after 0, we are taking the blue graph. That means this.
Okay.
Okay.
Got it. Because even I thought that sharp edge, so can't
No.
make this differentiable
Yeah,
by the graph.
So that
Ma'am,
is why we are
1 second, could
deleting
you
this portion
go
and
2 step back? I am
Sorry
confused
to
about it.
interrupt. How, say, can you explain that x is less than 0? So we cannot understand, madam.
okay. So what was the function when x is less than 0? We define the function like with this, and when x is greater than 0, we define the function with this, right?
Okay, this is the given condition, huh?
Yeah.
Okay.
This was the given function, right?
Okay.
So when x is greater than 0, less than 0, we will consider the red graph. That means this graph up to 0, right?
Okay. Okay.
And after 0, we will consider this graph. So we will delete this portion, and now we
Okay.
will delete this portion. So after 0, we will consider this.
Okay. Okay. Okay.
This is our
But,
domain now, right?
yeah. So, madam, in this question, see now, okay, now Yelango separately drafted the graph, but at the time, this kind of information, how we can capture in the Desmos actually? So we can directly
No. You have to
Sorry.
draft all the graph, and you have to then compare domain wise. Otherwise, you
No.
can fix the domain.
No, madam, I saw somewhere they are capturing exactly
Yeah. You have to
this.
fix the domain. You have to fix the domain.
Yeah, they're changing the domain in
Yeah.
Desmos.
So
Yeah. If you just change the domain of the first graph to minus infinity to 0 open, and the domain of the blue graph with 0 to infinity, then you will find the main graph.
yeah. Yeah.
Correct.
Okay. Anything else?
Understood.
In that function, we are
What is the
equating
question
into.
actually from this question? What is the question?
Yeah, this is the question. So here, like x tends to 0, we are putting the left hand derivative and right hand derivative, right?
Yes.
So from there, actually, mod x will vanish, is it? So when I'm substituting 0, everything will get vanished. So how we are getting 1 here?
From
Can you
here.
explain it again? Yeah, ma'am. Yeah.
So if you take h as common, then you will get h cube plus 1, no?
Yeah.
So if you put 0 instead of h, then 1 will be there. Limit is tending to 0, h cube plus 1. What is the value? 1, right?
Yes.
And same for this.
Yes,
Right.
that's fine. Okay, in f of 0, we are substituting as direct 0, right?
Yeah. So we are just following the definition. F of h plus 0 means we will be considering h plus 0. Now h is considering to 0 from the negative side. That means we will consider this portion of the definition, right? Because h is from the negative side. So we will now follow the definition. If you follow the definition, then you can find this, right?
Correct. Got it. Yeah.
Yeah, ma'am.
Yes. Anything else? Any other doubts? Anyone?
No, ma'am.
Okay, so
Ma'am, in this question, see, since h to the power 4 plus h divided by h, if we put the limit h tends to 0, then it will go to like infinity by infinity form, like 0 by 0 form.
Yes.
So we can
you
use
can
the
L-Hospital rule. Yeah, sure. So if
Okay.
you use the L-Hospital rule, then again you will get the same thing.
Yeah, one will come in, like when we differentiate, h will become 1, so it will come 1.
Same, right? Someone has raised his hand. So if you have anything, you just unmute yourself and ask me. Okay, I am not seeing the screen. Okay.
No, I have done, ma'am. Thank you.
Okay. So is it clear for all?
Madam, related to the Desmos only, this condition, how we can fit into the Desmos, madam, exactly? It's a single row.
This condition?
Yes, entire.
Okay, that means when you are plotting a graph, you can adjust the domain of the graph.
No, that I understood. You explained earlier. So what I'm asking that see now Ilango two lines is given the input and he got the graph, right? So but in this that x is lesser than 0 or x is greater than or equal to 0 is not mentioned, right? So different line is entered in the Desmos. So
Yeah.
how we can capture entire this equation in the equation?
No.
in
You have to like plot the graph separately and set the domain. I mean, this is the only way, what I know at least. You cannot do this in single line. You have to plot both the graphs separately and then you have to fix the domain. Then you will get the graph. Okay.
Okay, madam. But there is a options is there because I'm not clear about this. So one line we can enter everything. So like that.
No. In one line we cannot enter everything. You have to plot both the graphs differently. Separately, first you have to plot the graphs and then you have to set the domain separately again according to the given domain. Okay. Then if you just set the domain, they will automatically omit the portion which is outside the domain.
Maybe I 50% I completed. Remaining thing I don't know. I'm pasting the what I did. Maybe you can understand what my question clearly. I think you are already told. See here another line, the division portion I cannot able to enter. So you can see the in chat box. I captured that x less than 0 also. But another the division portion I don't know how to capture in single line. So there is some options are there, but we don't know how to do. So here one portion with the limit, what is a x is less than 0 and all less than 0.
This is right. Then again add, go to the add sign, no?
But that is we are doing differently. That I understood different line, but same line how we can capture? That's only my question.
I don't think we can capture in same line. They are different polynomials, na? So you have to plot them differently.
Okay.
Yeah.
Understood.
So I don't know. I think it is not possible to plot them in single. I mean, in which way we can write them in our pen and paper, but we cannot plot this thing in the graph in that way. I mean, you have to plot them separately.
Okay, madam. So,
yeah. Okay. Anything else? Okay. So again, let us solve one question which I solved earlier during the practice assignment maybe, but still just to recall, suppose this is something given and again you have given the value of some f of 2 as 8 and f of 1 0 dash as 2. Okay. So you have to find f of 0. Okay. This type of question I already solved. So I expect you to solve this. I'm waiting for
it is an exponential function now. I mean, it's a to the power x.
It can be anything other than exponential too.
Okay.
Yeah. You cannot specify anything. I mean, there can be any function. We cannot list up them, right? So this is a function which is satisfying this property and this too. Now you have to find this.
If this, we have to assume that the function is a to the power of x, no?
What?
Ma'am, whenever we have this functional equation, we have to assume it's a to the power of x, no, ma'am?
No.
The function is a to the power of x.
No. Why? There can be any function. Like if it's some function which is satisfying this 3 property, not necessarily exponential function. We cannot list up all the functions. There can be some function which is satisfying these properties. you have to take this in some general meaning. You cannot take a specific example. If the example is satisfying all the property, then it's fine. Otherwise, you cannot take. You have to solve it generally. And the hint is you have to use the definition of derivative.
Okay, ma'am. What definition, how will we proceed, ma'am?
Okay, so this definition, limit h tends to 0 if h plus a minus or plus? Minus or plus? What was the definition?
Minus.
You have to use this definition.
Excuse me, ma'am. Can we, is the F0 1? Means I have written a very simple one. F2 plus 0 is equal to F2 into F0. So F2, 8 is equal to 8 into F0. So 1. Can we go like this?
Ma'am, it's 3.
Okay, let us check. Yeah, whatever you said, I guess I'm also going to follow this. So if dash 0, if you use this, so we have h tending to 0, f of h plus 0,
Ma'am, is the answer 3?
Okay.
Ma'am, it's f of 0 now, f of h. Ma'am, here you have written minus f of h or what?
H plus 0, and then this is 0.
Okay.
So
what is the value of f of h? F of 0 equal to 2. F of h.
f of 0 is 2.
Wait, ma'am, solving.
Wait. So f dash 0 is given 2. Right? Now limit h tends to 0. We have f of h minus f of 0 by h, right? So we have to find the value of f of 0 here, right? That means we know that this limit is already defined, right? So once we know that this limit is defined and this is something 0, that means in order to calculate the limit, this should be equals to 0, right? That means 0 by 0 form, right? If it is not in 0 by 0 form,
Ma'am, please explain it again.
yeah, if this is, that means it, because this limit exists, then we can automatically imply f of h minus f of 0 is equals to 0, right?
How?
No, sorry.
Why?
Okay, wait.
It tends to 0, not.
Yeah, wait.
Ma'am, a long time. I think the session it will be exhausted.
No, it's
No problem, ma'am. You continue.
Yeah.
But still, we're pending with so many topics, ma'am.
Yes, ma'am. You have to schedule one more session, I think.
No, yeah. No, ma'am. You just finished today.
Let ma'am
Let us
teach.
try. What?
Let ma'am teach.
Yeah. Okay, so that was the question. I got confused. Okay, we shall start from the beginning again. Okay. So the first question was this and second question was this. I was following them. Then I suddenly just, okay. So
It's okay, ma'am.
Yeah, I just mentioned this thing here right now. So the first answer of f of 0 you told as 3. I will check it. And what is the answer for f dash 2?
Must be 16.
Actually, I said the whole question.
What?
For the whole question, I said the answer is 3.
Okay.
Ma'am, if we substitute x as 0 and y as 2, we will get f of 0 as 1, ma'am.
Yeah, that is what we will do. So,
Ma'am, from where this f dash 2 came?
okay, so this is the question. I mean, you have to find the value of f of 0 and f dash 2.
Okay.
In
One
order
more
to
thing.
find them, we are applying the formula. So this will be f of 2, f of 0 minus f of 0 by h, right? F of 2, f of h minus f of 2 by h, right? Is it okay? Is it okay?
Ma'am, f of 2 could not understand.
Okay, so f dash 0 means we have to put a this is 0 and 2 instead of a, right? Now we are applying this thing. So f of h plus 2 will become f of 2 f of h minus f of 2 by h. Okay. Now we can take f of 2 outside. Then we will give this. By h, right? Correct?
Yes, ma'am.
Yeah. Now we know the value of f of 2, which is 8. And this is nothing but f dash 0, right? Provided f of 0 is equals to 1, right? Okay. So why can we imply f of 0 is equals to 1? Because we know this limit exists. That means this limit should exist, right? That means this should be in 0 by 0 form, right? Because h is already 0 here, right? So f of 0 should be 1, right? Because if the limit exists, then we have to apply the L'Hopital rule here, right?
Yeah.
Is it fine? So if suppose if f of h minus 1, that means f of 0 minus 1 is not equals to 0. Suppose this is not equals to 0, then we will find something finite over 0, right? Which is not defined, correct? F means something finite, okay? So some finite number over 0 means which is not defined. So once it is not defined, that means automatically the other hand will be not defined, right? But we know that the other hand is defined. F dash at 2 is defined. Then only we can find the value of f dash 2, right? That is why we have to assume this part as 0. Any doubt?
Ma'am, so what is the value of f dash of 0, ma'am?
F dash of 0 is given, na? 2. Okay.
Okay.
So the value of f dash 2 is 16 and the value of f of 0 is 1. Okay.
Okay.
Ma'am, can we expect this sort of model in the exam?
Yeah, you can expect this type of thing. So this type
It
of
is a PYQ question, ma'am.
yeah. Also, maybe I solved this type of question in the practice assignments, right?
Yes, ma'am. Actually, I was the one who was asking this.
Yeah. So yeah, I can
Now
remember
it's cleared,
this.
ma'am. Like that time also I wasn't cleared much. Now, yeah,
Okay.
now it's clear.
Now is it fine?
Yes, ma'am. I need to practice once again. No problem. Yeah, please move on.
Okay. So yeah, if anyone doesn't have any problem, I can move. So the next topic, what I want to say is,
Ma'am, just 1 minute, ma'am. Scroll up, please. Yeah, okay, ma'am.
I
Thank you.
will share the notes. Don't worry about it. I will share it in the calendar.
Ma'am, in calendar, it asks for the access.
Yeah, I will provide the access. Okay, so in this session, it's maybe from the. Okay, I will share the notes in the chat box. Also, I will share it in the calendar. Okay.
Okay.
Yeah. Okay, so next we have a critical point. That means we know as per the definition, if f is a function, then we can derivative, f is a differentiable function, then we can determine the derivative. And if we find the root of the equation, if we have this equation, then equation is called critical points, right? That we all know. So if I have a function, the root of the first derivative of the function is called critical point. So once we are talking about critical point, that means it can be maximum. Like we have only three possibilities, right? It can be maxima, it can be minima, and it can be saddle point, right? So it's maxima means we will get this type of peak, right? That means before the point we will get something increasing, and after the point it will be the graph will be decreasing, right? And minima means before the point graph will be decreasing, and after the point the graph will be decreasing, right? So maxima means increasing to decreasing, and minima means decreasing to increasing, right? And sudden point is those type of points which are neither maxima nor minima, right? Okay. Saddle points are those type of points. So the thing is, suppose you have a graph like that. Okay. Suppose this is a graph. Okay. Now, if we check this point, at this point, this is a maxima, right? And this is a minima. This is a again, this point is a maxima, right? After seeing the graph, we can consider them. So at this point, suppose this is our x1, suppose this is our x2, suppose this point is x3, and this is x4, right? So if I consider f dash x equals to 0, and then we are finding the roots of x, that means the roots of the equation f dash x, which are basically x1, x2, x3, x4. That means we have f of x1 dash is equals to 0, f of x2 dash is equals to 0, and up to x, same for x3 and x4, right? So f of x1 dash is equals to 0 means at the point x1, the tangent is parallel to the x-axis, right? Because 0 means tan 0, that means theta is equals to 0. That means the tangent will be parallel to x-axis. That means the theta between x-axis and the tangent is 0, right? Similarly, for the point x2, this tangent will be 0. This point x3, this is called saddle point. You can see this is neither maxima nor minima, but still at the point x3, the tangent is parallel to x-axis. Rather, it is exactly the x-axis. And at the point x4, again the tangent is parallel to x-axis. Okay. So critical points means those points. At those points, the tangent of the graph will be parallel to x-axis. That means the root of the equation f dash x equals to 0. Am I clear?
Yes, the slope is 0.
Yeah, right. The slope is 0. Okay. So this type of points are called critical point. Now we have a test called second derivative test. And what is the second derivative test? It is saying that we can first we can find the roots. So roots will be critical points. Then we can compute the double derivative of x. So we have three type of possibilities. This can be greater than 0, it can be less than 0, or it can be equal to 0, right? So if it is greater than 0, that means at some point, suppose at x1, then this x1 is minima, right? Then this x1 is maxima if x is less than 0, and if equals to 0, then we cannot comment anything. Then like if double dash 0 is also 0 at that point, then we cannot conclude anything from the second derivative test. That means test fails here. Okay, so this is the second derivative test. So if you have any function, yes,
if double derivative of x is equal to 0, it can be minima also.
it
Am I
can
right?
be minima, it can be maxima, it can
Yes,
be,
yes.
saddle
But
point
we
also.
cannot comment.
it
Yeah.
can be, yeah, it can be saddle points also. So
Yes,
we
yes.
cannot make any comment. In that case, the process is you have to draw the graph and then you have to check. Okay.
Yes, yes, okay.
For quadratic equations, what we will having the double derivative won't exist for them now.
For quadratic equation,
The double derivative won't exist for them.
why? This will
It's
be a
there.
this will be not equals to 0. For
They will,
quadratic equation, we can always find double derivative.
Double
Right?
derivative of a
So square
quadratic
plus
Double derivative will be
constant.
constant, na? Some constant.
the double derivative will
A
be
value,
some
value of
constant,
A.
which is not equals to 0 basically, because quadratic means a is not equals to 0, right? So the
Double
double derivative will
derivative,
be 2a, right? So it can be greater than 0 or it can be less than 0. That means either you can find the maxima or the minima. That means vertex always exists now. So the vertex will be either minima or maxima.
yeah. This is the first derivative. Well, after doing the second derivative, we'll get 2.
This is the first derivative, right? If you find
Yeah.
the value, then you will get x equals to minus b by 2a. That is why we take the vertex as minus b by 2a from this formula.
Yes, ma'am.
Right?
Yes, ma'am. Yes, ma'am.
If a is a 2a, this is the double derivative, right? That means
Yeah.
2a. If this is greater than 0, then we will have a minima, right? So again, we know that it is greater than 0 means a is greater than 0. Then we will get a parabola in the upward direction. That means we will get the minimum point, right?
Yes, ma'am. Yes.
Similarly, it is less than 0 means maxima. So 2a is less than 0 means a is less than 0. Then means the parabola will be in the downward direction and we will find the maxima, right? So yeah, all the things, all the facts which we know about parabola, these are basically consequences of this our formula. Okay.
Yes, ma'am. Got it.
Okay. So if you have any formula, what?
When we conclude the saddle point,
okay, so saddle point we cannot conclude. I mean, when this is equals to 0, then it can be anything. It can be maxima, minima, or saddle point. Okay.
okay, ma'am.
Next, we have integration, right?
Yes.
Yeah. So we know that because for following the Riemannian integration, we know that if we have any curve, any graph like that, any arbitrary graph, so we can find some area bounded by the graph and some interval, right? Some a to b and bounded by the graph. That means this area, right? We can find any this type of area. So this is a formula that a to b, suppose this graph is fx, so fx dx, right? So area bounded by the curve is, we can find using this formula, right? So from the integration part, I'm not going to the basic because I guess all of you know, and if it is enough to know, like recall this portion of the
Yes, yes, ma'am.
for the exam purpose. Okay, so I'm not going to basic because it's already late. Just for example, let us solve one example. Suppose you have a function f of x equals some okay. Suppose this is our function, and we want to calculate the area bounded by the function in the interval 0 to 1. Okay, that means you have to find this integration. This is just for rapid practice purpose. Just just solve this equation and let me know what is the value.
Ma'am, can you explain the Riemann sums?
Yeah, sure, I will explain. Okay, first solve this one, then I will explain the dimension.
Ma'am, I have not get a single PYQ from this Riemann sum concept.
Okay, I will revise the Riemann sum. First, just solve this integration, then I am coming to the Riemann sum.
Next session.
No. For Riemann sum, we cannot conduct one single session.
Okay.
Ma'am, here do we need to use integral uv dx?
Okay. So because you have to sometime observe the function. If you can put something.
Excuse me, ma'am.
Yeah.
Can you please explain the by parts method property?
Okay, I will explain.
And
Here,
substitution method.
but here you don't need to use the by parts. Here you have to substitute. So once you have this one, you should have noticed that you have cubic term here and you have square term here, right? So once this type of thing is there, you can substitute this as some t square. Okay. Then after derivative, we'll get 27 x square dx equals to 2t dt, right? That means x square dx is equals to 2 by 27 t dt, right? Now we will just put them. So we have then 4 root over t square and x square dx. That means we will put this. So this will be 2 by 27 t dt from 0 to 1, right? Then just take the constant term outside. So 27, sorry, not from 0 to 1. We have to change the limit. So when x is equals to 0, t will be equals to 1 plus 9 into 0, that means 1, right? And when x is equals to 2, t square is 1 plus 9, right? That means t will be root over 10, correct?
Yes, ma'am.
So these are our new limits, 1 to root 10. Okay, so now we have t, we have here again t, so t square, then t square dt. Now we can clearly find the derivative. So this is 3 into 27 t cube from root 10 to 1, right? That means 8 into 27 into 3, 10 power 3 by 2 minus 1, right? So this is how we can use the substitution method. So once you know, if you substitute something and if like after substituting, if you can simplify the equation, then you have to substitute accordingly. Then you have to change the limit. This is mandatory, which I forgot to do. So you have to change the limit after substitution. Then you have to simply calculate the integration using the using the formulas which we already have, right? Any doubt?
No doubt. Ma'am, a small query, differentiation is a bit more weightage part, sorry, integration is more weightage, but which sort of questions are to be expected?
Okay, from integration, you can only expect simple, straightforward question. I mean, just some function and you have to integrate it in some boundary. That means you have to find the area bounded by some curve. Okay.
Like not even this much complex, ma'am.
No.
It's more easy on x square integrations.
Yes.
Either you have to maybe use the substitution method, otherwise partial, by parts. That's it. Just these two methods are enough. Yeah.
Okay, ma'am.
Like you have to only calculate the integration, which you all have already done in your 12th standard, right? So nothing more than that.
Okay, then we have to mug up the sine to cos and cos
Can
to
you
sine.
please concept by parts method?
Yeah, sure.
Ma'am, actually, I have a doubt, ma'am. What
Yes.
is meant by linear approximation and home summation? Something.
Linear approximation.
Yeah.
Okay. So I just let me list your doubts. Linear approximation. Then by parts.
Homogenization something.
Riemann sum.
And substitution, ma'am, also.
Substitution I just covered now. That is what you have to do. You have to substitute the function. You have to calculate the derivative and then just calculate. Same thing which you have already done in your 12th standard. This is what you have to do in substitution. Okay.
But one rules, which question to apply, just like.
Okay, there is no rule for substitution. You have to use your intuition for the substitution, and for that you have to practice the problems. Okay.
Suppose, ma'am, one question. Sine inverse. Sine inverse plus.
Sine inverse?
Plus.
Sine inverse what?
Sine inverse, 3/2.
Sine inverse 3/2.
Yes. Plus. Cos inverse.
Cos inverse.
Now find the integration, 6 to 8.
Is cos inverse what?
Inverse what?
Cos inverse 5/2.
5/2.
Yeah.
Integration?
6, 8.
There is no x. This is totally constant. What do I have to do here?
This is just like a put value and then the find.
You don't have to do anything here. This is simply a constant, na? There is no x. I cannot see any x here.
Yes, it's a constant.
It's a constant. So you can take this outside. Dx means x is the integration. So the constant term into 6 to pi. That's it. Constant means you don't have to anything.
Simple integration.
Simple integration. Just x. Nothing. Okay.
In exam point, actually, this integration Riemann sum, both are similar, or different question will be asked?
In exam, you will not be asked to calculate Riemann sum or what. Riemann sum is only for your conceptual purpose. Okay. You should know the origin of integration. This is what Riemann sum's role is. Yeah. You don't
Sometimes
have to,
they will ask the approximation, right? Left approximation, right approximation.
Yeah, there was some question in your graded assignment or practice assignment maybe, but in exam I don't think there will be that type of question. But left approximation and right approximation that we know, right? This is for just knowledge. Okay.
And this critical point, there will be one question, right? Like
Yeah,
it will be like
yes,
a
yes.
polynomial.
Yeah, right. You can expect one question from the critical points. Yes.
Okay,
If you
basic
say,
polynomial in
then
that.
it will definitely come.
Yeah, you can expect. Yeah. Okay. So Riemannian sum. One of you just told Riemannian sum you are facing problem with. So Riemannian sum is what? Once you have a function, suppose we want to calculate the derivative, Riemannian sum is nothing but it is the origin of integration. Okay. So using this, we can find the integration, the formulas and all. Okay. So first step was we have to partition the interval. Once we have the interval, we can partition the interval, and partition means what? We will divide the interval in sub intervals, right? X1, this is suppose some x2, and continue like that. B is some xn, right? So this is our partition, x1, x2, xn. So partition means these are the points in increasing order, and this is equals to b. The end point is the b and the starting point is the a. Okay. So what Riemannian sum says, once you have the partition, you can find the functional values, right? So this is the functional value of f of x0. Let us denote it with y0. This is y1. This is y2, and so on, right? Y3, y4, and up to yn, right? Now, using the Riemannian sum, this simply use the method to compute the area of a rectangle and then sum them. Just you have to add the areas of the rectangle. That means you have a area for any arbitrary curve. So you have to part the interval, that means the domain of the curve, in some sub interval, and then you have to calculate the area of the rectangle. That means here first we can consider these rectangles, like this is the first rectangle, right? Then this is the second rectangle. So this is the third rectangle. This is the fourth rectangle, and this is the fifth rectangle. Okay. So if you calculate the area of these rectangles, we know how to calculate the area of the rectangles, right? So this will be, if we want to calculate area of this first rectangle, this is base into height, right? So height is f of 0 and base is x1 minus x0, right? Then we have to sum the area of the second rectangle, that which is nothing but x2 minus x1, that means base of the second rectangle, and the height is y1, that means f of x1, right? In this way, we will move and we will cover all the rectangles. Okay. So you can now see, if I calculate the area of the rectangles, then we can find the area which is approximately same to the area which is bounded by the curve. Okay. But once the scientist, he noticed that if I increase the number of points in the partition, suppose if I introduce one more point here, okay, x6 maybe, okay, and one more point here, x7, then our new partition becomes this, right? So we have this rectangle, then this rectangle, then this rectangle, then this rectangle, then this one, then this one, then this one, right? So the red one is after increasing the number of points in the partition. Okay. So you can see this part of the error, this red shaded part of the error, it was error earlier when x6 and x7 was not a part of our partition. But when we include these 2 points in our partition, then this portion is become like not a error. I mean, this is now outside the set of all errors, right? So this is now part of the area. This is now become part of the area. So thus Riemann noticed that when we increase the number of points in the partition, the error decreases. Okay. So the point is increasing the number of points in partition, we can decrease the error. Okay. Okay. So once again, we are finding the approximate error here, right? So we want the less error. So he noticed that whenever we increase some point in the partition, we can find the error to be less from the earlier error, right? So he just tried what can be the maximum possible point in the partition. If I denote the number of points like xi, and if I tend I from 1 to ... n, if I tend n to infinity, that means if there are infinitely many points in the partition, then we can find the error to be something which is very less, that means tending to 0. So we can just like avoid the error in that case, right? So the approximate area will be almost same as the area bounded by the curve in that case, right? So Riemannian sum is nothing but this portion. That means f of xi, and in this portion we can denote it with delta xi, and sum, where I is from 0 to infinity. That means this is the area of rectangle AI, right? Area of rectangle I, right? Rectangle I means ith rectangle. So this is the first rectangle, this is the second rectangle, this is the third rectangle, and we will proceed up to infinity. Okay, so this is the Riemannian sum. So we first consider infinitely many number points in the partition. Then we can find infinitely many number of rectangles, right? So once we have infinitely many number of rectangles, we can find area for each of them. Then we will sum the area. Okay. After doing all this thing, which I get, is called Riemannian sum. Okay. And this is approximately same as the
integral.
Yeah, integral. Fx. Okay. This is the story behind the integration. That is how we started thinking about integration. Okay. So integration means basically summation. Like we use sigma when we sum something, right? But when we have the interval as something very small, I mean, just for if I use the natural number to sum,
Continuous.
then yeah, so we can then pick natural number one by one after 0, then 1, then 2, then so on, right? But sometime if I take the whole real number, 0 to 1 means some portion of the some interval, like some one portion of the real number, right? In that case we cannot count because this is uncountable. In that case we use the small sigma or integration. Okay, this is for uncountable purpose, and summation we use for countable purpose. Okay.
In statistics also, ma'am, integration is
Yeah.
used in continuous random variable.
Yes.
Which we can't count.
Yes. So once we cannot count our domain or the points in our domain, in that case we define it with small sigma. That means the integration. And once we count the points, then we define it with capital sigma. Okay, this is the definition. Otherwise, the summation and integration is same. Just the countability of the domain. Okay.
Yes, ma'am. Because this just 0 to 1, this is containing almost infinite numbers between these two.
No, this is not infinite. This is uncountable. Like uncountable is something beyond infinity.
Okay.
Infinity means you still count. Natural number is infinity, but
A
you
very
still
big
count,
number.
right? And uncountable is something beyond infinity. Okay.
Oh.
In the case of uncountable, we use this. Okay.
Okay, ma'am.
Yeah. Okay. Okay. Now integration by parts. So this is, you have to simply follow the formula where u and v both are functions of x, and you just have to follow. You have to choose one function which is differentiable, and you can you can help to differentiate the function. So just suppose I choose this u as our first function and this our second function. So first you have to maybe fix this function u, then you have to integrate the function v. Then you have to first differentiate the function u, integrate the function v, and then again whole integrate the whole function. My u or v are same. Is it fine now? This is the rule for integration by parts. Okay. So
Excuse me, ma'am. This is the u for integration. Then v is constant, no?
No, why constant?
Yeah, whole's integration.
If b is constant, in that case, why do you need by parts? Both are function
u
of
is a
x.
constant. Both the function of
Both are function of x. Okay. For example, suppose u equals to x and v equals to log x. Okay. Okay, both are function of x. Suppose we want to find the by parts of this. Okay, dx. Then in that case, we will use the integration by parts. Suppose this is our u and this is our v. Okay.
Okay.
Yeah. So u is first constant. That means x. Okay.
Ma'am, do we need to use isolate for u and v selection? Like, which one first we need to take?
Yeah, so you have to take accordingly. I mean, which is for here, just for example, if I take v here, I just took v equals to log x, but this is not possible because if I take v here, then differentiate integration of log x will not going to help us, right? So you have to take u here and v as
integration of log x is x log x minus x, na ma'am?
Yeah, but this is not going to help us. I mean, we want something shorter, right?
Yeah.
So if you take u, it will be more complicated. So I don't want log x as v. Okay. So I can take u as log x and v as x. Okay. Then we can do it more simply. So x dx, then
Madam, it is isolate rule, right? Isolate.
Yes. One by x. That means 1 by x means this is the differentiation of log x. Okay. Then integration of log dx. Then again dx. Okay. So now just follow. So 1 by 2 x squared log x minus 1 by x 2x squared. No, sorry. 1 by 2x squared dx. So x will be cancelled out. Then 1 by 2 x squared log x minus 1 by 2 x dx. So 1 by 2 x squared log x minus 1 by 4 x squared. So this is the answer plus constant because this is yeah. Okay.
Yes, ma'am. Okay.
So this is the rule you have to use in case of integration by parts. Okay. And about linear approximation. So for as of now, just take linear approximation is nothing but your tangent. I mean, what is the equation of tangent? One we have f dash x. So at the point x, we can at the point x naught, we can define the equation of tangent, which is nothing but y equals to x minus x naught f of f dash at x naught minus or plus was there. Any one of you can just Plus or minus? Any one of you?
Plus, plus,
Plus, right?
Plus, plus. X minus A.
Okay. So this was the tangent at x naught, correct? This is nothing but
correct.
linear approximation, right?
Ma'am, at x naught, can we take anything, ma'am?
Yeah, x naught is a finite point. I mean, if you can take any point at which the function is differentiable.
Yeah, okay, ma'am.
Yeah. So this is the linear approximation of a function. Once you have to calculate the linear approximation of some function at that point, that means you have to use this definition. This is the linear approximation. Okay, this is nothing but the equation of the tangent. Okay. Anything else? I covered the portion which I intended to cover today. Now, if you have any doubt, you can ask.
Ma'am, homogenization means?
Okay, so homogeneous means basically the same power. I mean, in order to like just for if you have double variable function, so this xy, so the power here and power here both are 2, so this is kind of homogeneous. Otherwise, if you take this this is one kind of homogeneous, you can say. I mean, this power will be same in that case.
Okay, ma'am.
Yeah.
Thank you,
For
ma'am.
the exam, some other
Okay.
question pattern or something.
So for the exam, I must say, whatever I covered today, this all this example are important from the exam point of view.
Okay.
So
So this one.
Yeah.
Okay.
It is enough if you just follow this type of question.
Okay.
Share the notes, ma'am.
Yeah, I will share the notes.
And good sleep is also required. Good sleep
Great,
is
great.
also required.
Okay.
Okay, thank you, ma'am.
Welcome.
You are great, madam. Continuous non-stop 3 hours. I don't know, without water also you're not taking it, I think.
Yeah, you be patient and you took the session.
It's
Yes,
my job. I have to do it.
Nice. We also
people are
actively
asking.
listening. Yeah, listen mode. So whatever.
Without hesitation?
Yes.
Great.
It's inspiring, ma'am. I feel
what-
you are enjoying your job.
Yeah, sure. Obviously, I enjoy.
Without frustration, nothing.
So this is my work. Now I have to like clarify your doubt. This is what
No,
I'm supposed to do.
See, same way,
No,
plus
your
two, we in school days, plus two, our teachers are very explained us. So maybe we scored a good score.
yes. No, excuse me, ma'am.
Thank you, madam. Thank you.
Excuse me, ma'am.
Yes.
One of your colleague joined my company. Like he was instructor in IIT Madras. Now he is in my company now.
Okay. Maybe I don't know because I joined recently here. So
No, he's teaching. He was teaching DBMS. Now he's
okay.
working with
So
Government of
I
India.
don't know him then because I just joined recently after like before 2 terms.
Oh yeah, okay.
Ma'am, if nobody
Are you
has any
MTech
doubt,
student,
I
ma'am?
have
No,
sent
I'm
a
a student. Yes. What?
ma'am, I have sent a image in chat box. Can you see it?
Yeah.
Like one of my friend.
Just wait. I can check it once. Just let me check it. Yeah.
Like one of my friend, I don't know, he makes me fool or what. Like he wants to prove that 1 is equal to 2. Like how can it be possible? If 1 is equal to 2, then the whole fundamental of maths be wrong.
Oh, he cancelled x minus x from both sides. 0 and 0
Yes.
cannot be cancelled.
Legends doing math.
Okay. Yes.
ये मुझे pick up backside.
Yes.
This I was also sometimes confused about it when I was maybe in 9 or 10 standard.
We cannot make it no, because as it is in
Yes, 0 by 0.
multiplication.
Yes.
Yeah.
We cannot divide it by 0. Okay. if anyone can
It
prove
was
that 1
it
is
was
equal to
one of
2, then the
your
whole
friend or it
fundamental of
was you?
no. No. If anyone can prove that 1 is equal to 2, so the whole fundamental of math is proven wrong.
Obviously,
1
there
plus
is
1 is
obviously
equal to
some
4.
error. Then you have to find the error. That is what mathematician's job is.
Yes.
This whatever showed, it's wrong only, no? So it's showing, see, you cannot say the one side is the same variable, another side, instead of division, you are bringing as a
Yes.
changing the sign. That
You
is
solve it like
wrong. That
very
is wrong
fastly, like
actually. That
see
is
x
wrong.
is equal to x, then
Yeah,
x minus
so
x cut
it should go by division only, right? So we should not
Yep.
bring as a sign conversion.
Okay, I just check it once. I shared the PDF. Can you open it?
Yeah, we can.
It's
Yeah,
fine, right? Okay.
one more legend thing there was which was equating 0 to 1 with the exponents.
0 to
0 to 1 and 0 are equating in the exponent form.
Yes,
Something like that.
logarithm by using logarithm. Yeah.
With the logs.
Yes. So Madhav and Ilango have sent a image in chat box. Can you draw this image without lifting your pen and overlapping on any line?
This image is not open.
Yeah, we can, no?
Please try once.
Okay. Let us play this.
Yes.
Okay, you try it. I don't want to try it right now. You just take it as your homework.
Because it takes my 1 hour to draw this. Okay, Lango, just
Yeah, you just take it
line
as your
group.
homework.
Okay.
I got hanged right now.
No, ma'am, I have food. Actually, dinner also, most of the people didn't take dinner. Okay, from 8 o'clock, even 6 o'clock, there was a session. 6:30
Yeah.
TA session and the
Yes.
statistics session.
That I know.
Today
Yeah.
fully.
Okay, if you don't have any doubt, then it's end for
We can
you.
wind up.
Yeah, you can.
Yeah.
Thank you, ma'am.
Okay, ma'am.
Have a good day.
We'll
Excuse
meet
me, ma'am.
after NTERM
Hello.
next
No,
term.
after will you come in?
Next
Because no,
term.
you next term.
Excuse me.
Let's see.
No, no. I'm not going to come from next term because I will be in maths 1. So you are leaving maths 1. Maybe this is the last class by me.
So then you'll fail again and you will study again. Then that's the only way.
No. Don't do this. I never want you to fail.
Fail again and study again. Come for this session.
Don't take it
You should grab full marks.
Yes.
All the best for all of you.
Thank you.
In your end term. Yeah.
Thank you, guys.
Thank you, ma'am.
Yeah.
Welcome.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
Welcome.
Bye, ma'am. Good night.
Good night. Okay, if anyone doesn't have anything, then I will end the call. Otherwise, if you have anything to ask still, I'm waiting. You can ask.
Actually, can you share the notes? I'm not able to open.